Let's do it.
Let's do
We never
this.
know. We never know when we're actually live anyway, so just click it,
Attack.
push it.
Pretty sure we're live.
That we are. It says we're live, so we're here, and I'm here with Brad of Sonic Gravity and Alexei Novitzky of the Noviverse, and I'm happy because we had technical difficulties. I'll just leave it at that last night, but we're back here tonight, and I'm excited. Both of these guys are pretty cool. I like you guys. You're cool. I like
Thanks for having me.
Did you see Alexei and I talking about you last night about how I said you sounded like Brad Pitt sometimes the way you said it's a fact. It's,
That is a fact.
that's a fact. I swear it
That is a
sounded
fact.
when you're looking at the video and you hear it through the headphones, it sounds just like Brad. And I was like, ironic, irony. His name's Brad.
Yeah. Yeah, except I look way better from way further away. See what I mean? That's the one thing that we don't have in common. He's prettier the closer you get, and I'm prettier the further away I get.
I think he's wearing a
We're
lot
sort
more
of like
makeup.
we're sort of like Cooper pairs, like anti-particle pairs there.
Well, what do you all want to get into first? I would like to, I mean, I know we were going to talk about what anti-gravity and then this hologram thing. And I don't know
Sure.
if you watched last night's any at all, but I was complaining about the hologram issue and that
Yeah.
and I do this in jest mostly because I obviously don't have the scientific background to argue against it. I have to use my intuition, but I do like to discuss it. It's awesome to think about the possibilities.
Well, I would not discredit intuition. I think if when we're talking about it, if when we leave the conversation and you're not saying, "Oh, okay, that's plausible," then that means one of two things: either I suck at talking about it, or it's not true. Right? So,
Well,
I
but
mean,
people have
you
deep
know,
deep biases. That's not necessarily true, right? Some people aren't that objective. I mean, I'm trying to be an objective person. So you know what I mean. But deeply
yeah,
biased people can't come out of a conversation with their minds thinking, can that be true or is it possible, right?
I think there's truth to that. You're right. I think you're totally right. But I really do like this is not something where I just started thinking about this like a couple of years ago, or maybe a year and a half ago. So I'm not married to any of this. I don't do this for my day job. Like I don't. If some guys, if they're wrong, like maybe they don't eat, or maybe they don't get any more research. They got vested interests. But I think if we don't leave this conversation, and you're not saying, okay, I can see it, like maybe don't agree with it, or you're not really sure. But if I can't at least convince you that it's plausible, that doesn't speak well for essentially,
Well,
the viability.
you're a couple of steps already there because after watching your video, I mean, I try to go and watch especially if I have some amount of respect for someone. When I'm watching their material, it's like when I watched Alexei's material, I'm like, I gotta meet him because I went into it with an open mind, and I like it. I like the approach. I like both of your approaches, and I just think this is what we need in science is some out of the box thinking.
I think
Whether it's right or wrong, if it gets those people who are stuck in their box to at least think of a different method, different way. I think that's important.
well, I thought it was
Lexi's
great
like,
too.
what box? What box? What are you talking about?
I thought it was great that your challenge was also honorable mention. Congratulations.
Thanks,
Yeah.
you too, man.
Yeah.
No, I mean, I
Yeah.
think that's awesome. Like, so there is, in my opinion, right? Because I think we kind of say very similar things. Like, I think there's a lot of credibility behind what you're saying. But then, like, so that's where we have our biased opinions, right? Like, Artisan's a 10 to the 10 on this side. I'm 10 to the 10 over here. You're probably over here with me almost. But then it's like we talk to Artisan, he might move this way just a little bit. And I think that's a win, right?
Yeah.
And
Well,
I got to
yeah.
tell you, like, Alexi, like you and me, like when we start talking, like, I think the one place where we both intersect is consciousness is transacting on the surface of the holographic universe, on the 2D holographic surface of a black hole. And it's just like now, except he's talking about what happens inside your consciousness, right? Because I think we both agree that your consciousness is energy on the surface of the black hole. And he's talking about like what that means and how that looks. And I'm just talking about how the physics translates, how everything we know and measure in physics translates to a Rosetta Stone of the universe that has us on the surface of a black hole.
Right.
And so, and one of the things that is just crazy. So Stephen Hawking is credited with, essentially establishing for the consensus for proving that on the surface of the black hole is energy, and the energy is actually containing information and comes off the surface of the black hole as what they call Hawking radiation. And one of the upshots of his discovery, and this is consensus, this is not woo or really kind of disputed, is that the energy must come from the black hole, which means black holes evaporate. And it's his theory that it's this Hawking radiation does it. Now, to me, when I saw that, when I first heard that, I was like, oh my God, the consciousness on the surface of the black hole, when we die, that's our consciousness coming off the surface of the black hole, carrying the information that we've recorded in our memory and DNA away, carrying that information away from the black hole. Like it matches exactly with what Hawking's saying. And one thing that corroborates that is the celerity of the hummingbird. So if you think about the reason he said that the black hole evaporates and is because the energy that comes off of the black hole must be from the black hole, which means our consciousness is on the surface of the black hole. And so now time, if we're on the surface of the black hole, just stay with me. If we're on the surface of this black hole, if our consciousness is, and time, right, we're going through time, right? Like, I don't think that's in doubt, present, past, future. But if we're stuck to the surface of the black hole, then we're not going through time. Time is blowing through us because we're moving through time, and it's not time, it's space time, which means it's space and time. So the universe is expanding because space time is blowing through us, and we're on the surface of this black hole, and time is blowing through us too. And so that means that space time, if the surface of the hologram is the surface of the black hole is a hologram, space time blowing through the hologram changes the hologram, and that's what we notice is the passage of time. Because we don't have like an organ that says, oh, now it's 3 o'clock, it's 4 o'clock. All we can do is see the change in the hologram, essentially the change in the picture of what we see. That's the only thing we notice is the passage of time, which means, and this is crazy, but listen, just stay with me. That means consciousness slows the flow of time because Hawking proved the energy on the surface is fixed. And when we're conscious, we're using that energy to run our brain. But that means that there's energy. Since it's fixed, that means there's energy that time can't use to change the hologram. So we are constipating the flow of time by being conscious. And now it makes perfect sense that when we sleep, time moves faster because we let go of the energy. Time has it to use to change the hologram, and time moves faster while we sleep. But when we're awake, time moves much slower, which is why 6 hours in a traffic jam feels a lot different than 6 hours of sleep. And the crazy part is this. So if you think about the part of your brain that sucks the energy off the black hole, right? It's your neurons. Well, the neuron density of a human brain is 53 million neurons per gram. The neuron density, the synapses, right, that fire the synapses, the neuron density of a hummingbird's brain, 650 million neurons per gram. So the hummingbird is sucking way more energy off the black hole by being conscious. And that's why the hummingbird beats its wings at 200 times a second. It doesn't have fast muscles. It has slow time.
Well,
and
that's why. Let me interject. Let's.
Sure. Go ahead.
Let's give each other. Let's take this in little pieces so we can discuss little pieces at a time.
Sure.
I remember one of the original arguments. What's that, Alexa?
No, I like opened up my book to a specific page. I would like,
because
I need to read this page to you real quick.
I
It's
remember,
online.
I'm an old guy, so I remember some of the original arguments. But because Hawking originally thought that information was not preserved in black holes, right? And then we came to this realization that it might be that it is preserved, or that it's maybe the black hole is recycling, the way I like to look at it. So we get the gas, we get plasma jets out of the center of the black holes, right? But I guess my point, what I'm asking is that when I hear him talk about information being lost or preserved, it's not that it comes out as it went in. When the information comes out, it's back to bits, right? When it went in, it was organized ones and zeros, but when it comes out, it's just scattered, right? It's not organized anymore. So that's the only problem I think I have with this idea that if our spirit or consciousness or whatever lives there and then it escapes from the black hole, I don't think it's going to be organized in the same manner.
I'll play devil's advocate to that point real quick.
Okay.
Maybe it's not organized within our dimension, but from the dimension of the flow being ejected out of that radiation beam, it is organized. So from a different dimensional perspective, maybe that radiation is perfectly organized already coming through.
And what kind of dimension? Like, I think of dimensions like height, width, then you could like have time.
Like, outer and inner dimensions. I remember when you were talking about your pace intro, how you mentioned maybe when we go into the next layer of the black hole.
Yeah.
That's exactly what I'm talking about. Layers within the black hole.
That makes perfect sense. I get that. Because on the hologram, right, it's a 2D holographic surface, right? And so there is like a dimensional, but I think the dimensional sort of step is the translation to the next universe. You get kind of one more dimension. So at least in my, so you have like the multiverse, right? We have a black hole. And I think that our universe is inside this black hole. We're on the surface of the holographic surface, sort of looking in. And the way I sort of think of that is like, think of like a fishbowl, right? And so like, say there's like a fishbowl and there's a bunch of fish and everything. And if you like put your head to the fishbowl and close your eyes, right, then your consciousness is on this fishbowl. And then all of a sudden, now your brain, your consciousness is receiving sort of impulses, like signals from the surface of the hologram. And it's like all of a sudden, boom, now you have the perspective of a fish that's like inside the bowl. And the way I sort of can rationalize that is the same way as if, you know, your brain sits in this cave inside your skull, right? It sits inside of a sensory deprivation chamber, and your brain doesn't touch anything. It shouldn't touch anything. It doesn't see anything. It doesn't hear anything, but it receives inputs. It receives little electrical signals from your nerves that say that you interpret that information. And that's what I think of as information, not as like bits and ones and zeros or whatever. It could be bits and ones and zeros, but the information you're receiving, think of the information your brain receives from your nerves. It could be like little pulses or whatever. You can, if it helps you to think of it as like numbers or whatever, but you could just say that your brain receives information from your nerves that your nerves get from its senses. And that's information. And it's just how your brain sort of translates it. So when you think of, oh, we're on a hologram, I mean, if it helps, like our consciousness is energy on the surface and it's receiving like zaps maybe from the holographic surface of the black hole. But what we're interpreting it is as the universe around us, the same way our brain doesn't really see anything, but it gets a signal from our optic nerve, and our optic nerve gets it from our eyeball that interacts with, you know, other energy or whatever. And so it's really, if you can conceptualize that your brain is sitting in a sensory deprivation chamber and all it's receiving is little zaps from your nerves, then I don't think it's too much of a stretch to think of your consciousness. It's not inside your skull anymore. It's just on the surface of a black hole, and you can't feel the surface of the black hole anymore. You can feel the inside of your skull.
But how do we have, I guess we can all agree that black holes have, very dense objects in the center of them with huge amounts of gravity, right? I mean, so How do how do how do how do we?
That's
How do
actually
we
not
just,
what I think.
how
I
do,
don't
how
think
do we?
black holes are.
I'm trying to kind of use
I would
the.
say that energy is all relative. So compared to where we are, the energy within the denser black holes is denser, but the energy outside of us is less dense, and that's why the cosmic microwave background is the less dense.
But we've observed black holes tearing apart stars and galaxies, each sucking them up, right? So how do we maintain the hologram on the surface of the black hole with such gravity just beneath it?
Okay, so let me tell you what I think a black hole is, because I don't think a black hole is a big, bald, dirty mass like everybody else thinks. Because what happens when a star collapses, right? And you can sort of think of it like an ice skater, right? So when the black hole or when the star gets far enough along in its life that it essentially, now the consensus is that it starts making iron. I think all it makes is neutrons. I think hydrogen's crushing into neutrons, but I don't want to like totally go down that rabbit hole right now. But that's why a neutron star is what leaves if the black hole doesn't. It's a solid core of neutrons. But, and just a prediction, we will see that ICF, internal confinement fusion, the fusion that they just did, is going to leave neutron residue, not helium. It's going to leave pure neutrons, and that can't, those are neutrals. They can't be contained in magnetic field, and that's going to cause lots of problems. But you're going to see that, and we're going to realize that neutrons are generated from hydrogen. And when those, like, these are like 3 quarks in a proton, which is like the nucleus of a hydrogen atom. And you'll see, like, when 2 of them get pushed together, like so, becomes a tetrahedron. See how it's even on all sides like that? Okay, that's what neutral means. Any way you slice it, if you look at the charge matrix, if you look at my theory of everything, I derive the charge matrix in the Dirac equation. And so it's like just as positive here as negative right down the middle. It's a neutron. So a neutron is not one atomic mass unit. It's 2. And this is a neutron. And when the neutron is neutral, it kicks off both the electrons from the hydrogen. That's where your solar fusion energy comes from. And that's why the core of every star is a neutron. And that's why a neutron star, when something supernovas and it's not big enough to become a black hole, it's a neutron star. But so the thing is, that was weird that I had that right there. But anyway, so think of a star collapses, right? And the mechanism of collapse, anyway, just pretend you're a consensus physicist and it starts to make iron and steals electrons, and that's why it collapses. That's not true.
Endothermic. It goes from exothermic to endothermic, and
that's what they think. But and that's like a whole nother thing. But we'll just go with that just for now. But so anyway, so imagine a star is like millions of miles wide, right? And it's like an ice skater. When it collapses down really fast, what happens is it's like an ice skater. When she jumps up in the air to do a triple axel, she has her arms out. But when she's up there spinning, she pulls her arms in. She spins up really fast because there was spinning energy when she jumped up with her arms out. But that momentum has to be conserved. So when she pulls her arms in, it takes less energy to spin her, but she has to stay at the same energy, which means she has to speed up. So if a star is millions of miles wide and it's spinning, it's got a certain initial angular momentum, and it collapses down like an ice skater really fast, it spins up really fast. And if at a certain size, the law of angular momentum forces that star to spin faster than the speed of light. And normally that's not possible. But if anything were to spin faster than the speed of light, Einstein said it goes back in time. It has to go back in time. And so that's what I think is happening. And in my theory of everything, I did the math on it, and I showed that when the core of a star collapses down, like right in the very center, right, it's not going to be going very fast, right? Because like the single point right in the middle, it doesn't really spin at all, right? I mean, it may be just, but it's kind of just one point there. And if you go out a little, it spins faster, faster, faster. Well, at a certain radius, it's going to hit light speed. Further than that, because it's like swinging around, anything further than that is going to be faster than light. And so what you're going to have, if you do the math on it, you're going to have a donut of space inside that star when it collapses and spins. There's a perfect donut of space inside that star that would spin faster the speed of light if what I'm saying is true. So there's a perfect donut size, piece of space that's going to spin faster than light and go back in time. That's what Einstein said would happen if it went faster than light.
Did he say you would go backward in time, or time would slow down for?
At light speed, time stops. You're right. But faster than light, it goes back in time.
I always imagine approaching light speed is that problem of going halfway each time. You never actually get there, right? If you're going to point A to point, yeah,
that's what resolution on the hologram. That's how you get depth on the hologram. Is the resolution gets smaller and smaller and smaller and smaller. So when you talk about you can go halfway, then you can go halfway there, then you can go halfway there, and you never quite get there. That's how you get infinite distance on a hologram. So you don't have the depth on the surface of the hologram. You have information on the surface of the hologram, but the depth that we see, that our consciousness detects, is resolution on the hologram.
What about
so you have height? Sorry.
I was just going to, sorry, I don't mean to interrupt you. I just have all these questions.
Sure. But you were talking about for what the black hole is.
Oh, I know. And I'm still there.
What you have is like this quantum gravity. When something goes back in time, and so time dilation, right? When you hit the gas in your car, right? You go faster. You go faster through space, you go slower through time. That's why even though you go faster through space when you jump out of an airplane, you don't feel gravity, because your speed is slowing your time, but you're falling deeper into a gravity well, which is also slowing your time. So you never experience the curvature of time. But when you're in your car and you hit your gas, your speed is slowing your time, but the gravity is trying to hold it the same. So that tension between the curvature of time, between you dilating your time as you're speeding up, but the gravity trying to hold it the same, there's something called the Lagrangian. It's kinetic minus potential. But you would essentially have kinetic energy slowing your time down, but then negative energy trying to hold it where it is. And so you'd get like you'd feel that negative energy. You'd feel that tug. When you go up in a rocket, you're going out of a gravity well. And so that's speeding up your time, but you're also going faster, which is slowing your time. And so then you have like a minus kinetic minus a minus potential, which is like double, right? It's like -2. And so that's a lot of negative energy density. -2, that's like a lot of tension that you feel. That's a lot of pressure, gravity that you feel when you're going up in a rocket. If you go faster than the speed of light, you go back in time, which is, it's just an extension of, if we can just say, okay, just suspend your disbelief, you go faster than light, you go back in time. Well, now think of the universe, right? The surface of the black hole at one snap in time is the state of the energy of the universe at one instant. Now imagine every time, and then there's another one, there's another one. So you could essentially say the universe is like a movie. You could peel the surface of the black hole off at every point in time like a sheet, just like a frame in a movie, and stack them from the beginning of time to the end of time, from the Big Bang until like the end of the universe.
Would you say the beginning of time to the end of time, or from the center of time to the edge of time?
Yeah, I mean, like however you want to style it, totally. However you want to do it, or from the outer, right? Because when you look out, like from the end,
you get what I'm saying.
Yeah, totally. I mean, you can. I think there's totally room for you can all kinds of. It's language, right? We're trying to communicate in terms of language, and
totally.
And I don't think anybody's got a monopoly on language, but if you stacked, I call them slices of cheese, but if you stack every slice of time, right? So now when you have like when you have like tension in that string, when you're dilating your time back, right? And so say you dilate it back a teeny bit just because you took off in your car. So your time dilated a teeny bit, slowed a little bit down. Well, if it went back in time because you went faster than the speed of light, it goes all the way to the beginning of time. Okay. And the gravity that in that tension, the same way you feel the gravity in the back of your car when your time dilates a teeny bit from hitting the gas, the tension in the Higgs string from that gravity going all the way back to the very beginning of time, because you can't. So say, okay, so the mass of the star spins faster than light, say. It has to go back in time. Well, it can't go 10 minutes back because it can't land in time back there, because conservation of mass energy says it has to be the same. So it has to keep going. So once you go faster than the speed of light, you eject all the way to the back before the beginning of time, because no time can accept it, because the law of conservation of mass energy says energy can't be created or destroyed. So that's how you get that Einstein-Rosen bridge that goes all the way back to the very beginning of time, where the space in the star, the core of that star brought space with it. Excuse me. I'm going to cough.
So how do we, that's a good time for a break though. How is this information? So is the information stored for each slice?
Well, right. So if you took a snapshot, and this is what, and you said eventually it was accepted because, and I wanted to throw some credit at the physicist who did it, Gerard Tahouf, and Leonard Susskind, just brilliant physicists. Those guys took down the Hawk. Like the Hawk said, information is destroyed in a black hole, and those guys were like, contraire mon frère, and they figured it out, and they said the information could be imprinted on the surface of the black hole, and that's what we're observing. Like we are observers observing the universe, and we're recording information in our DNA, just like Gerard Hoof and Leonard Susskind said. And when we die, our consciousness leaves the surface of the black hole as Hawking radiation, carries our information with it. I think to the primordial black hole, which is heaven, but some people think it could, manifest on the next black hole up, which would be like, now Alexei says it's less dense because it seems like it's getting bigger, right? Or maybe you take it
in quotes, heaven direction would be less dense, in my opinion.
Yeah. Now I have a little bit different view of that, because I think we're 2D on the surface, but we're inside a 3D on a 2D. So in some ways it's strange. You and we haven't talked about this, and I wanted to bring
just talking about it though.
We'll
it less dense would be more related. Less dense would be more related to light to me than.
When I say dense, it's more about electromagnetic or matter densities.
What?
Like every point in space the way I see it is like almost every point in space could be considered the center of a black hole, but you can break it down into those magic squares to where you get the fractality, which creates the depth that you're talking about. But the original primordial energy, in my opinion, would stem from the greatest, biggest, most outer region of a black hole. And then within a black hole, there's actually different information structures. And so as you get closer to center, the rotation rate becomes quicker, and that produces faster frequencies. So in essence, the fastest frequencies come from closer to center. The slowest frequencies come from the outer edges. Is the easiest way to put it. And so our consciousness is kind of like created from 6 bands of harmonics, delta through fast gamma. And so each one of those waves is interacting with a different layer as that raw energy is drifting inwards, like you mentioned, lighting up the different layers. So I talk about like a 6-layered black hole, essentially, that we have access to, but the physical realm only exists within the beta waking state, alpha beta waking state, and slow gamma.
But what about the other black holes that we observe? How do they play into the main black hole?
So I think the black hole is, so if you look at the math on a black hole is a donut, and it's a holographic donut, and the space that used to be inside where that black hole is gone. It's back in time. It's at the bottom of that Rosen bridge that goes all the way back to the beginning of time, and we're on the surface of it, receiving information from the hologram about the universe that's inside, that went all the way back to the beginning of time. So a black hole, and if you look at a picture of M87, look at a picture of Sagittarius A star. Now they'll tell you that, it's a donut. Just look at it. It's a donut. And what you're looking at, I think, is the space that just ripped out of our universe and went back and started another universe. And so you have donuts that are we see black, and we're starting to see these black holes. And by the way, they took a picture of Sagittarius A star, which is the black hole that's at the center of the Milky Way galaxy, and it looks like an oval. And they can't figure it out. And so they did all this like modeling or whatever, and they tried to make it look like a black hole and all the orange around it, but it's not. It looks like an oval, and it looks like an oval.
Just perspective, I guess.
Well, it is, because if you look at a donut from the side, it looks like an oval, doesn't it? And since we're spinning around Sagittarius A star, if you were looking at Sagittarius A star and I was right, then you would see an oval. You would not see a circle. And if you can find those unretouched images, they say, oh, it's distortion. That's why it looks like an oval. No, it looks like an oval because it's a donut. And it's a donut of space that ripped out of time. But if you look at M87 that's edge on looking at us, then you'll see it is straight up a donut. And the reason that it's a donut is because we're looking straight down the barrel. Now, we talked about how our consciousness, if I'm right, like our consciousness is sitting on the surface of the black hole, and we know time is passing. So that means time is blowing through us, which means space-time is blowing through us, because it's not time, it's space-time, and we're on the surface.
Quick question about that. When you say that, are you saying that time that's blowing through us is coming from the outer realm's inner, or from the inner realm's outer?
It's coming from the inside. It's the quantum gravity. It's the tension in the Higgs string, right? The time dilation is pulling that space-time out of through that Rosen bridge, and it's uncoiling into our universe, which is why space expands and the universe expands the further out we look, is because space-time is uncoiling out of every single black hole there that we have. And the reason when nothing falls into a black hole, because space-time is blowing out of it. So there's no situation where anything falls into a black hole. But what happens is that anytime it eats a star or something, it's a donut shape. But you can imagine like this donut, right? Well, in the center of the donut, there's space like blowing into, it's blowing out of the surface in the middle, which is causing a jet. And that's why in pulsars, in all these black holes, that's why if it eats a star, you see it blast out a jet out the top and bottom. Like, that's not an accident. It's because, oh, sorry, go ahead.
No, I was just going to say, before I forget, sometimes sure. I blurt out because I'm afraid I'm going to forget something to ask. Yeah. But
if I talk too much, shut me up.
No. When I saw your diagram, I imagined it being the horned toroid that connected in the middle. To me, that was more of a, I don't know. It seemed more of a cyclical thing than just the donut. But you're saying, do you know what I'm talking about? That
sort of, I think I know.
The toroid that is connected in the middle. That the regular donut is like this, but I think they call them horned toroids.
Okay,
they're connected and they have a little. So they're the cycle of it. They're at some point joins in the center.
Okay.
Y'all keep talking. I'm going to look it up right quick.
Well, if you take a star and you collapse it like it's a ice skater, and in the very first, like, sort of, I don't know, 15 minutes or something in my theory of everything on YouTube that was in the pace competition, I draw it out and I do the math and I show where the radius is, and I color it in so you can see like a 3D drawing of that. When I say donut, I mean it's like a donut. And the core, remember we talked about sort of the neutron core of the star, like if it doesn't become a black hole, everybody knows it becomes a donut. Yeah, so like I think it's kind of the one in the middle.
This is like the horn. This is the horn torus where it connects, and this is just the regular donut, right?
Yeah.
This is how I always visualize. This is how I visualize black holes, where this part is a black hole on a separate universe. Like the line between the universes is right here where they meet.
What they're not showing is the radiation blowing out the tops and bottoms, and that's what happens when you get the flow to come this way, and then it laminarizes and goes straight up, and that's how you create those longitudinal waves.
Anyway, that's how I've always visualized black holes. I don't know why. I don't know. Just, it's probably not correct, but that's
well,
how
I don't know. I mean, it just kind of, like I'm not, I mean, I don't have a monopoly on the truth. All I can do is, I mean, I've just tried to put together what other like brilliant physicists I think have taught me. And this is just kind of the way I see it going together. And when I saw the picture of M87, I'm like, that's a donut. Nobody can tell me. I'm like, dude, like a year ago, I said it was a donut, and I mean it. It's a function of spin. It's not a function of mass. Because if you actually do, like, if black hole theory was right, if you think about all the mass of the star that blows out in a supernova, what makes the nebula, the energy from that, the energy of the explosion, then there has to be enough energy or mass left over to create the gravity. If you take the initial energy of the star, you just don't have enough. If you look at the flash, if you look at the the size of the nebula and the heat and all that kind of stuff, there's just not enough energy there. So it's something different. And I think it's space ripping out of time, going back in time. And when you consider, if you're catching what I'm throwing in terms of consciousness on the surface of a black hole, then everything starts to fit and it starts to make sense. And so I don't think anything goes into a black hole, maybe not because it couldn't. I mean, maybe it could, but there's space-time blowing out of a black hole at the speed of light. And I think it just turns into a great big particle accelerator where all that space in the center of the donut, in the middle, where it's blowing in from all edges, creates a ton of pressure space, which is like an accelerator. And they can't figure out why the gamma ray burst hits us before the flash of the supernova. And I'm like, dude, it's because there's space. It's like a big jetway of space, like at the airport when you don't want to like walk all by yourself and you want to cheat and you want to walk on the escalator that's like a flat escalator. Well, that's like all that space. It's like they're just lazy. I mean, a gamma ray
riding
burst
the
is
natural
just
flow of
lazy.
space-time. Like legitimately, you're creating a longitudinal flow of space-time, of time, of space, of the raw. So that's why I say the raw energy of creation. I don't know what word to use. So like that's
I don't know.
Yeah, I mean, and that goes faster than light.
Well, I think neutrinos are sort of a carrier of space-time. I think essentially if there was the voxels, the little spots, the little points where anything could have a value, it's neutrinos. And that's why there's an extremely high neutrino density that comes out of the center of black holes that, along an axis. Like if you look at M87 pointing at us, we just got hit by a gamma ray burst in October of 2022. And so here's the sonic gravity predictions based on what I call the Rosetta Stone of the universe. One, the gamma ray burst we just got hit with rode here faster than light on that jet stream of space-time, that it comes from the pressure of being on the axis down, looking down the barrel of the donut of that black hole. My prediction is that the supernova that's going to accompany that is going to get here in a year or two or whatever.
That's what I was about to ask you. So how much faster do you think it goes than light? Because I was leaning towards like 1.612 is the number I get.
I mean, because there's a lot of, and I would have to like speculate. Well, here's the thing. So I think the weak nuclear force is like osmosis, right? Osmosis for like entropy, like spreading everything out, making everything equal, right? And so I think that the reason that that neutrino flow, that space-time flow, is faster than light down the axis looking down the barrel is because there's a lot of neutrino pressure, and the weak nuclear force is like, hey, I don't want things bunching up like this, and it's trying to spread things out. So in some ways, at the end of the day, those neutrinos are flowing faster than light because it's space-time. And nobody, I don't think any physicist will say, space can't. Everybody knows space can go faster than light. So space itself can go faster than light. Matter
within that space, light is the barrier, is what they say.
Yeah,
I personally believe that's a function of evolution.
But the way I've always imagined space is that it's a fabric that permeates all universes, right? Not just our universe. That when infinity was created by my creator that I believe in, that was sort of the sandbox, and then the little universes were.
That's where we're trying to find the right words again, because when we're saying empty space, or if we're saying time, it's like before it has become length, before it has become matter, or like depth.
Yeah,
So
Mhm.
before
but
that,
that's the only thing reason I have a
I call
trouble
that
with
spirit.
the
Yeah.
matter. I have a problem with the matter in our universe. I know it can obviously affect space time, the fabric of it, but I don't think it's the same material. I don't think it's the same material.
Okay, well,
You know
so
what I
now
mean?
you're in some ways you're talking about, general relativity and how energy deflects space-time, right? And so,
Yeah.
and that's so when I go over the way I unify quantum mechanics and um general relativity is, so now I want you to think at any instant in time, we're looking at the holographic surface of the black hole, right? Which is in the shape of a donut, just by the way. So it's a 2D holographic surface. We're on it. We're recording information at the bottom, essentially at the bottom of the Rosen Bridge, just like you put your head at the, fish bowl, and then all of a sudden you're a fish inside, and you look up at the cosmic microwave background, but that's really, you're looking back at the inside of the fish bowl, right? When you do that. So,
One time the speed of light outward.
yeah. I mean, it's just like, well, it's really just you're looking at the maximum resolution on the hologram.
Exactly. I totally
So
see what you're saying. Yeah.
yeah,
But
so it's
isn't space time sort of like the superhighway that light travels on, that time and
yeah,
light travels on? So
yeah.
it doesn't have to. Nothing really has to travel faster than light, right?
Well, so I think, well, through the speed of on the hologram, right? There's a limit on the hologram. Like if you're going in the X direction, in the Y direction, or if you're going in the resolution direction, getting smaller and smaller and smaller, light, like there's
Inner
a limit.
or outer.
Yeah.
Yeah.
And like you say inner, outer, I say lower, higher resolution. But the speed of light is definitely a thing there, because, and here's, so, and I'll tell you why. So I want you to take the surface of the black hole and peel it off and hang it like a sheet at one instant in time. Okay. So you've taken the surface of the black hole off, you peeled it off and hung it like a sheet. Now, matter and energy, this is where my definition of sort of when you talk about extra dimensions, right? So you're on the hologram. Now our consciousness is on the surface of the hologram, and that's where we get our information from. But we know that energy oscillates, right? Quantum mechanics, right? Energy oscillates. It's U1
It's all in
orbit.
a circle.
Yep.
For my opinion. Yeah.
Yeah, no, it is. And so, but if you draw the line that is the surface of space-time, right? And remember, this is, and you think of like the energy or whatever, it dents the space-time, right? And that's what gravity is. So the surface of the black hole, which is where our consciousness is up and down. You have energy going like this, right?
It
Now
hits it twice.
it hits it twice. Yeah. And so, and in quantum mechanics, when they talk about like the wave equation, right? It's an oscillation. This is U1 symmetry, which is the energy zipping through. Now, when the energy hits going forward in time, like here's the surface of the hologram. So it hits this way now it's going forward in time, positive charge, this spin, and then it goes through the hologram, and then it comes back around, and it's the Higgs field that leashes all of the matter and energy to time on the surface of the black hole. It goes back around and it comes through and bam, it hits the other side. Okay, now it's going back in time, negative charge, opposite spin, and that's antimatter. That's antimatter right there. It's because remember, we only get our information from the hologram. So when the energy hits, it ticks right here. That's where we see it. It comes back. It's dark matter when it's off the hologram, and then it hits here and it's antimatter. Then it's dark matter again.
Antimatter
Can I
rare?
throw a picture real quick?
No. Well, no. It's a antiparticle pair. They see them all the time. Quantum entanglement, right? They take a particle, they zap it with a laser beam, and
Those
then they
two particles. Those are two normal. They're not. One's not antimatter, and one.
Yes, they are. They
Really?
are. They are antiparticles. It is an antiparticle. It absolutely is.
Brad,
I thought they were just two standard particles.
No, it's an
Tony, I want to share a
antiparticle.
picture real quick, and I think
It's
this
an
will,
opposite spin, opposite helicity, and then
I knew they had an opposite spin, but two particles can have opposite spin, right?
yeah. Now listen. Now with that in mind, somebody, whoever's watching this at the end of this, like whatever, hit
I'll show you
pause.
guys in a second.
Hit
No,
pause.
no.
Go watch I'm sorry. When we're done, like you just
Screen share. Screen share. No,
I'm saying
I'm sorry, I had to call.
Kurt Jaimungal had a podcast episode with Dr. Abhay Ashtikar, and what he said was, there's a particle, there's a relationship, and then there's an antiparticle of opposite helicity and all this. So it's loop quantum gravity. They're talking about the same thing. Loop quantum gravity fits exactly what we're talking about. And
I
so,
thought you were wanting a screen share.
No, I had this wide open.
That's what I was trying to get you to do.
I'm showing, and so how would we actually perceive? So if it's doing it's doing a smooth orbit, but
it's
we have
dark matter off
here.
the hologram.
We have our line here. This is, you could say, less dense off the hologram, more dense off the hologram.
See, I say future past.
Less dense is past.
Okay.
More dense is future. So then you could say that as it loops through, like literally, matter from below returns as light from above.
Okay, that seems like it's on all fours. I think.
So what's the frequency of that cycle?
Well, so here's the
depends on the particle.
Well,
I was going to say just real quick, it depends on the particle, the frequency, the natural frequencies of those particles, in my opinion.
Yeah,
that makes okay.
What I think I know is that the thickness of the hologram is 1 unit. I used to say 1 Planck length. I don't think it's a Planck length. I think in terms of Planck constants now. But so I see a 4 length diameter, which means it's 12.55 essentially units in a circle. If you take out the 1 for the top where it goes through the hologram there, and 1, in the bottom where it goes through as antimatter, that's 2.
Yep.
And so now you have the 2 to 10.55 ratio, which is 1 to 5.25, which is the exact measured ratio of matter to dark matter in the universe.
Exactly. Dark matter is just matter orbiting outside our perception.
Off the hologram. Yep.
Yeah.
So I always thought dark matter was a separate type of matter. But
dark matter has never been directly
ADG
observed.
hasn't. Yep. That's
all
exactly right.
All they see is like the gravitational effects, and that's where galaxies form around.
Now, and here's the beautiful thing, and it's true. It's still true, because when you draw that line, if the Higgs field is gravity, and that's what's leashing the matter around, even when it's off the hologram, it's still tugging on the Higgs field. It's still tugging on the surface of space-time. So when it goes like this, the energy, so when the energy's swinging out, it's still tugging, right? And that's why energy deflects space-time. And so now you have
unification. I have a symmetrical problem in my head that 80 we think the universe is comprised of 85% dark matter.
Mm-hmm.
How could it be that prominent if it's just the other side of normal matter?
Well, no. So if you draw your surface of space-time right here, and it's oscillating through, right? It intersects the hologram, because remember, it's only observable matter when it's real, when we can see
it's on the hologram.
When it's on the hologram, because that's where consciousness
gets the top of the orbit or the bottom of the orbit, but not.
But wouldn't there be a symmetry though? Wouldn't it be?
Yeah, but there's intersection.
Wouldn't we think that dark matter is 50%?
No, because remember, it's a 4 length diameter, right? Because if the Higgs string was 1 unit, it wouldn't engage, right? So it has to go 2 units to engage, right? Because everything has to be a certain length, and if it's a certain length, if it's the exact same length, it's not going to engage. So it has to go past it before it'll get whipped around, right? So there's 2 points of contact. Imagine it's a sheet, right? And so the leash is leashing the matter and energy to the surface of the hologram. Now, when it swings through, it punches through the hologram in one little point. Okay, that's one of our quantumly entangled particles. It goes off the hologram, and we can't interact with it because our consciousness gets its information from the hologram. So when it's dark matter, we can't interact with it. We only know it's there because the gravity is still tugging on the surface.
We can interact with it gravitationally, just not physically, matter-wise. Matter can't interact it, but gravity can.
Yeah, and if you do the math, so Tony, if you do the math, is pi times diameter, right, for the circumference of the circle.
Right.
So you got 1 tick that's in the hologram on top, and then 1 tick that's antimatter in the bottom. So that's 2 ticks out of 12.55, which is 2 to 10.55, which is 1 to 5.25, and that's your 15% to 85% dark matter.
Oh snap!
I think
Right?
it's cool. I think it's great. I say matter from below returns as light from above returns as matter from below.
Well, let me
Yeah,
ask
it
you
is.
this.
It's looping through,
is.
and I
So
say
get-
effects of synchronization because it's still creating effects of synchronization within those inner and outer realms, and those are all effects of mind somewhat collapsing the wave functions into our perceived realities.
And that's just it. Like, it sounds complicated when you don't have this vision of what it means to intersect the hologram and be observable. But if I told you, Tony, if I said the energy was 100 if I told you the particle energy was 100, but is it mass? Is it velocity? You don't know. How can you tell? What do you have to do?
Ratio.
Yeah, but you have to make an observation. It has to hit the hologram for you to know, because it could be 10 times 10 or 10 squared or 10 plus 10 plus 10 plus 10 or 50 plus 50 or 25 times 4. You don't know what makes it 100. There's so many what you call degrees of freedom in there. It could be anything. It's only when it hits the hologram in quantum mechanics that you can make an observation, go, oh, it's 10 squared. That's what it is. And then it swings off the hologram, and it comes back around. And then what is it going to be this time? Oh, it's 99 plus 1. It could, you see, the change, essentially the uncertainty arises from the degrees of freedom that can transact when it's off the hologram. So that's why you get.
Why don't we have to use the term hologram? I'm almost on board if I could just come up with a term like fabric,
Surface of the black hole.
Do it, man. Do whatever you want. Like,
I like using the surface of black holes.
I guess the reason the thing that, I'll be honest with you, that annoys me the most is not you or your.
It's not you.
Be honest.
It's not you.
It's the gamers who think when you say hologram, they have these visions of lasers shooting up, like we're not real. Or
we're in a video game.
It's all a hologram. It's all a simulation, man. And if I can get past, if I can get off, I
don't know though. It's hard to say though, because maybe when it comes to our consciousness on the holographic surf, the only way I think for the physics to work out and for unification to happen, because that's what unification is. Unification. This is U1 symmetry. U2 symmetry isn't three-dimensional, this and that and the other, because off the hologram is weakly interacting. The only thing it is tension, which is the Higgs tension that's leashing it. And so if that's the definition, now tension in the Higgs string, which is gravity, is pulling on the surface of space-time and deflecting it. And that's what Einstein was looking at. And that's the unification of quantum mechanics and general relativity, because general relativity says energy deforms space-time. And I just showed you how that happens. And so that's why I think that it all goes together, and I think it fits perfectly. But the thing is that it's only when they say hologram is really, in some ways, it was like Leonard Susskind and Gerard Hoof, and those were the guys actually Maldacena was one who tied, or Juan Maldacena tied, these are other like PhD geniuses. I'm trying to just I don't want to take credit for it because it's not my idea, but
the configuration is
but it's the resolution. Dr. Matt O'Dowd. Sorry again.
Information matrices.
Yeah, you can think of it like that.
Yeah, I mean, I would almost.
That's how I say it. Like there's information matrices that exist in different densities.
But if you realize that on the hologram, the depth, right? What we think we see, the depth, is really just resolution. Things in 2D just getting smaller as they optically appear further away, because that's help a simple mind like mine thinking, how do we get these three dimensions if it's a two-dimensional hologram? Well, so
we observe, we can observe things. When I do CAD work, right?
I feel like this picture does a good job of that.
Whenever I look at my CAD drawings in two dimensions, they kind of depress me.
That's the information matrix that exists on the 2D surface, but it creates depth based off of the inertial motions. Does that make sense?
Yeah,
So
I mean, like
so
I'm
it doesn't have any depth at all. I'm trying to
It's one
understand
half
how.
past and one half future overlapping to create the now moment, right? Because it's always one half past and one half future. And we have projections of mind that need to synchronize to create our fluid motions.
See, that goes with what I'm saying, where if you look at the hologram, right? Now is on the hologram, the past and the
Yes.
future. And so whatever's touching the hologram, and that's where you're getting your information from, that is now. So like I
Sorry,
know
I
when
agree.
you
I agree.
yeah, I mean, like when
Yeah.
you look at something in a lot of ways, it's like, modern warfare video games where it's like, it's like 3D or whatever. I mean, that's really a hologram. You're looking at a hologram where the resolution of depth is just like,
It's
things getting
sort of an
closer.
illusion though in a
Yeah.
video game, right? That's
Well, but it's an
done.
illusion. It's an illusion too, if all you're doing is receiving, zaps in your brain, based on the resolution of things getting bigger, and then all of a sudden, like, impact. You know what I mean? Like, it's just, I mean, imagine if, I mean, you're still just, it's just your experience. It's your conscious experience, and you're interpreting information, which is resolution and,
that's why I
other
think science
quantum
got stuck, is
data.
because they're only dealing with the surface, right? The physical realm, the
If
surface
you
of this
pretend you're in a 3D universe,
Yeah.
it gets really hard, and the
Yeah.
math gets crazy,
Yeah.
and all that kind of stuff. But if you,
I mean, we can shoot, I used this analogy with Alexei last night. I mean, I can shoot a laser at, a distant planet that's, billions of miles away, and I get feedback from that. How do you, I mean, that's not 2 dimensions. I mean, you know what I mean? How do I observe it?
you're okay, but now just close your eyes, okay, and try to imagine you're not actually seeing it either. You're not, like, all your brain is doing is interpreting signals from your optic nerves. Like, your brain is in a
But I can close my eyes and I can still perceive 3 dimensions. I can
It's a
feel.
function of
Yeah.
evolution within
Yeah.
a
but you
continuously
can't,
drifting inward.
oh, I'm sorry, go ahead.
No, you're good. You're good.
No, I'm saying your brain, though, is inside a cave. It's not actually seeing anything. You're just interpreting signals from your senses.
Right.
And so if you tell yourself that what you think you're interpreting as energy from your senses is reality, then you're going to get stuck in it's totally rational. It makes perfect
But
sense.
can we actually do science if we can't trust our observations?
Well, you can, you can, as long as you can account for them. That's like saying, like, just because I have an astigmatism, can I actually see? Well, if I can account for my astigmatism, then I can wear a pair of glasses and then I see a lot better. But I think if we have one of the biggest thing that we have to get over is that our perceptions could be flawed.
So let me just jump in real quick. I think it's a function of human evolution as well. Like, if we had a more advanced sense, we might be able to see more than just our hologram, or our surface of the black hole. And the reason I say so, we start off with touch, taste, and feel. That all comes from Earth, literally. And then when it comes to vision, that comes from the influence of the sun. So that's 2 orbits of experience. We only have senses from 2 orbits of experience. So when it comes to our perception of time, that comes from the 3rd orbit of experience, which is the distance from the black hole. And so now imagine we had another sense. I think we'd be able to see more and more and more. Like, we're limited. The human body itself is limited to the hologram based off evolution. I'm using the word hologram today.
Right. And we actually have a
it.
very narrow band of vision anyway, right? Because we can't see infrared light.
But also physical creation. Like, like we're tuned. Our most evolved sense is that of vision, and within vision itself is that narrow band of the visible spectrum. But imagine if we had another sense that we can't even comprehend because we're human. You say this all the time, like, we're limited to the greatness of all because we're in the human vessel, right? You say that a lot, and I agree with that statement. No, Artisan says that.
Yeah.
Oh, okay, yeah. No, I agree
once
with
we
it.
pass away, maybe
we'll
be
dude,
able to
I don't know if I said
more.
that.
No, you don't. I don't think I've heard you say that. I've heard artisans say that.
I'm gonna
And
say
so-
it now.
Well, I was gonna say, like,
I'll
what's the
tell him. I'll tell him it was yours, Tony. Though
That's okay.
I'll throw
Yeah,
credit.
no, but so like I think we're
Well-
limited. The human body itself is limited to our dimension, which is the surface of our experience.
And yeah, and that's exactly
Right.
when you say I see or sight. See, really, when you say you're defining that experience in terms of vision, but that's in some ways that's dangerous because there's a let me just give an example. So my wife and I, she started this dog watching side hustle with Rover, right? So like people are dropping their dogs off at our house and stuff. We had like 5 dogs over Christmas. So Christmas was like a giant game of who farted. And what was crazy was I'm in the kitchen and Ashley's like over in the living room and I'm like, oh my God. And she's like, oh my God. And seriously, the dog was probably 20 feet from both of us. Well, no, it was probably 40 feet from me. No, probably 30 feet from me and like 5 feet from her.
But which
Or
direction?
maybe
was the
10
wind
feet
going?
from her.
Where are
And-
the AC units?
Oh yeah, like
I'm
there's
kidding.
one upstairs and downstairs, but that's just it. It was so fast. Like I went, oh my God, and I was like, and she did the same thing, and I was like, when did you smell that? And she said, like 1 second before you said something. And there's just no way. The speed of smell
That is amazing,
is
though. I've
crazy.
noticed that.
The
I've
speed
noticed
of
that too.
I think
Yeah.
the speed of smell is like the speed of sound, but we
It
just
has to
have
at least be the speed of sound.
yeah, because there's no way there like the math. There was no way. There was no like breeze or anything like that. I mean, it was straight up. That speed of that fart was the speed of sound, easy, and it was just like, and so
Well, let's go.
that got me thinking. Our senses, it's just information that we're perceiving. And if you, so I think we boil in a lot of assumptions about our senses.
That's where I was about to ask. Do you
and what
think
reality is?
I mean, I know sound is longitudinal. I know vision is transverse. But do you think if you were to create a light wave that was within the range of human hearing, that we would see it?
I don't know.
The thing
Because
about
Paul,
it is,
in a sense,
I mean,
I'm
Or can you
I'm
hear
asking.
gravity? I don't know.
the thing I keep thinking is that we live in such a three-dimensional space. It's like sound propagates. It doesn't propagate in 2 dimensions, right? It propagates in 3 dimensions. Light propagates in 3 dimensions.
All
Everything
relative
that
to the
we
observer.
know, whether we're observing it or not, it right? Because it's like you all were standing in different places and you still smell the same thing. You didn't have to be lined up
Right.
2-dimensionally with the dog, to smell it, right?
Yeah.
So
I think it definitely there's something, and I just saw this on PBS's FaceTime, and it was about phonons. Space, no, yeah, but you
But
can
you might be
smell
able to smell
I
it.
bet you can smell it. Can't hear it, but
depending on how much it matters in the air. Right?
Could you smell it? I don't think so.
I don't know, man.
Well,
I don't know.
air is just made
It's
up
a
of
great
molecules,
experiment.
right?
It's
We
a
should,
great experiment.
We
I
should-
think
yep.
I think smell, and this is conjecture, right? I don't know. I haven't studied it or looked at it, but I think smell is a very quantum sense.
Mhm.
There's something about smell, and there's actually, and there's really nothing. It's just us interpreting information, right? So there's nothing that says any of our senses aren't like
But
really quantum.
isn't it just like light? I mean, the chemicals from that methane or whatever comes and it interacts with all the molecules between or atoms between as fast as say light or would, right? Maybe because
I don't know. Yeah.
light strikes that atom and it gives off another, right? It gives off another photon and so on. It's a chain reaction.
I've
And I
definitely
think
heard
it's a
theory about
phonon. I think there's something called phonons, which is essentially, and I think it's,
sound
and
donuts.
this is total speculation, but I think it's the pressure of the distance between neutrinos that transfers that information. I think neutrinos, like I think neutrinos is space-time flow.
That's what I'm about to
and
say. So
so-
you think of neutrinos as like the raw fluid of creation, then?
Yeah. Yeah.
Okay.
And okay, so the double slit experiment, right?
Yeah.
Okay. Everybody's heard of that. So the reason I think, and I could, I'm sure there's a bunch of physicists that would probably disagree with me. But the reason that light behaves like a wave, right, is because when you fire that light between those two slits, right, now, there's a bunch of light out here, right? But now there's only a teeny weeny bit of light that's coming through. And it's like osmosis in some ways, the weak nuclear force and entropy. There's like, hey, there's no light over here. Give me some of that. It kind of spreads out like a wave because I think that the flow of space, I think space blows through us because time passes through us. And so I think that space is very sensitive to, hey, to essentially to entropy, to, hey, what do you got that I don't got? Give me some of that. You know what I mean? And so that's why I think farts travel at the speed of smell. And that's why I think that, when light comes through those two little slits in the double slit experiment, there's a bunch of greedy neutrino flows that's saying, hey, spread it out, man. Don't be such a light hog. You know what I mean? And I think that's why I think it's, and maybe that's dumb. Maybe some physicists, have better ideas for what that is. That's my intuition based on what I've arrived at with the sonic gravity theory of everything and things that make sense to me. That makes sense.
I never thought that observing it would and the change that happens is all that big of a deal either, because there's no way to observe something without causing some kind of interaction, even on the quantum level, right? So
Sure.
just by viewing,
Well, that gives credence to the concept.
allows an interaction which can cause a change, right?
Well, but see here, remember we talked about the conscious hummingbird.
That's what
like
I was
the
about to say. That
conscious
gives
hummingbird
credence to the idea of consciousness collapsing space-time
It
itself.
does. It takes
Yeah.
energy off the surface of the black hole. I think that's a fact.
I'm just saying we're not really accounting
potentially. Maybe.
We're not saying that.
Most definitely.
Maybe. Probably.
Yeah, that's a fact.
So, but it's like, oh, go ahead, buddy.
No, I was just going to say that.
I got to read the line now.
Either way, it's not that like out there, right? Because either way, there's you're going to have some kind of reaction to an action, right? So even if you just glance at the photon and it takes a different path or whatever, then there's a physical. It could be a physical thing there or a more woo thing, right? Either one.
Well, you are part of the universe, man.
Right.
I think scientists we want to pretend we're not energy in the universe, and so that the things we do and think don't make a difference, because guess what? We are part of the universe. And so, and the hummingbird, when we talk about this, I talk about this from time to time, like the hummingbird, we talked about how consciousness is on the surface of the black hole. Hawking said the energy has to only come from the black hole. So that means when we're conscious, we're sucking some of the energy off the surface of the black hole. And that means time doesn't have that energy. Like we compete for time. We compete with time for energy on the surface of the black hole. So it's kind of like, the bathroom in the sorority house, right? Like, everybody is kind of competing for the same time and energy. And so whatever energy we're taking off the hologram to run our brains, and the hummingbird is taken off the hologram to run their consciousness, time doesn't have that to move the hologram. And that's what we notice is the passage of time. So when the hummingbird is awake, this is true. You can Google it. When the hummingbird is awake, not when it's flying, its heart beats 20 times a second. 20 times. Its heart beats 20 times. And it goes to sleep 1 time a second, just like us. And so, and if you look up implanted surgical sort of devices, time-telling devices, they call it like a problem with calibration. But no. And this is what I said. I said, here's a falsifiable experiment you could do. Take an analog clock, take 2 analog clocks, surgically implant one into a hummingbird where its heat is really what I think is slowing, its body heat is what's slowing down. It's sort of the bounds of the slowdown of time, because its metabolism speeds up to its heartbeat. So, it's just not just brain stuff. But if you took a clock, surgically implanted into a hummingbird, and then had a control clock on a desk, and then at some point took the clock out of the hummingbird, I guarantee you that clock would be way further in time forward than the control clock on the ground, because its clock moves, the time moves slower, which means when you play it back at, proper time, it's going really fast. It's like the Flash where everybody else is like, ooh, but it's moving around.
Even that could be a
online
physical
here?
thing. Even that
Yeah.
could be a physical thing, though, right? Because the clock could oscillate more towards the rhythm of the heart of the bird, the hummingbird. It could be a physical thing too, right?
Sure.
Like a
Yeah.
common oscillator, like when you hang two clocks on a wall.
Yeah, you can't.
They'll kind of tune to each
They
other.
tend to synchronize,
Right.
So,
But
it could
if
be a
you-
matter of thing.
Yeah. But put one in a human though. And if you look, there's all kinds of like, they call it calibration problems. Pacemakers, all that kind of stuff. Those things are notoriously impossible to keep on the right time. And that's because it's the same thing. The human body wouldn't do it as fast as the hummingbird would. If this is right, if this is true, the human sort of surgically implanted time device would definitely run fast compared to the same control on the desk or whatever. But I guarantee you it runs every single time. A device will run faster inside surgically implanted device inside a conscious creature compared to a control clock on a desk. I guarantee you. I mean, well, if that's not right, then I'm wrong and my theory of everything's wrong.
So that's a good experiment.
Yeah, it's falsifiable, man. And that's what I said. I have a episode called using consciousness to slow the flow of time.
Would negate your whole theory.
Yeah. I mean, well, at least that part of it couldn't be right. That's a prediction that has to be right if I'm right.
All right, I'm gonna have to do this now. I'm gonna read this little line real quick. And this is as I was developing my theory. This is from the section of the Crystal of Time. So you're talking about those snapshots. This is from the book, The Crystal of Time. Back to the example of gravity being a result of interstellar light pressure minus shielding from mass. And you see perhaps it is consciousness that is being shielded, creating wells of perception, which translates into gravity.
I'm trying to be there. I'm trying to follow that.
I feel like it's saying exactly what you're saying. Like literally consciousness perceiving things creates wells of perception. And so depending on your snap rate is how deep that well goes.
Okay.
But
yeah.
Can't we have, I've always tried to separate consciousness. Well, okay.
Perception. It's
I'm getting over the flu or whatever. But
yeah.
What I always try to do is I try to separate our physical realm from what I think is a sort of a spiritual, for lack of a better term, realm, right? And that consciousness is part of consciousness is just a physical, it's hardware that allows us to communicate or get on that, you know what I mean, with that on that level. And I forgot where I was going with that, but I know what I was.
How you like to think of consciousness, or
I like to think of consciousness as sort of a gateway, like part of it, like we have hardware as a part of our physical bodies that connects on that level. And so it kind of goes back to the question I had related to individualism and spiritualism and consciousness. Whenever the whole hologram thing, and see, I'm already softening already just by talking to you, but the whole hologram
You just said
thing,
hologram.
I'm going to say used to make me feel like that, there was no individualism, or, we weren't individual. We had no personalities. We were programmed. We were, you know what I mean? We had no choices in life, and we didn't have free will. All of that bugs me about the hologram. And maybe it's just an impression that I have about the hologram thing.
Well, here's the thing. And I'm actually going to drop an podcast episode about like ETs and interstellar life and how Earth is terraformed. But here's the thing that I don't understand why the scientific community consensus doesn't get it. So there's something called the principle of the stationary action principle. And what that means is that essentially energy takes the path of least resistance. I mean, that's kind of what it boils down to. And so I talked a little bit about the Lagrangian when we were talking about time dilation, where you have kinetic energy minus potential energy. That's the Lagrangian. So if say you threw a ball, you could draw out any path you wanted to for that ball to take. And if you took in every slice of that time, you would say, okay, at this moment, I'm going to take the Lagrangian, which is the height energy, or I'm sorry, the velocity energy minus the height energy. And you could do that all the way across. And whichever one came out minimum, that is the path that the ball would take. And that's because of the the minimum action.
It's the path of least resistance.
It's essentially the path of least resistance.
Totally. Yeah.
And so, but see, here's the thing, is that you exist, right? And Einstein proved E equals mc squared. Guess what? You're energy, right? That's a fact. Like you are energy.
Most likely.
And so, well, I mean, that's what okay. So you got to take on Einstein.
No,
yeah. You got to, if you can take out Einstein, then, then you could be right. But if E equals mc squared and you're energy, that means that you are essentially, your energy is the path of least resistance, which means you are inevitable. Because you're here, if you believe in physics and the stationary action principle, that means that you are inevitable. You are exactly what is supposed to happen now, period. And you can say that's God's will. You can say that's the minimum, that's the principle of stationary action. You can say that's the, whatever you want to call it. But and guess what? In your matter is DNA. And that means that there is DNA in your energy, and that is a fact. So you are made of energy. Oh, sorry. I was just going to say that means on any exoplanet environment, right? If the environment is substantially the same as Earth, if it's an Earth exoplanet, there's no reason to think that the cookie wouldn't crumble the same way. Like, we're not special. We're not first. The physics, the stationary action principle says the cookie crumbles this way. And that's just the way it's going to be. And so I think in any planet that's like an Earth-like planet, we come, like we get here.
Yeah.
You know what I mean? Like, we're God's plan as far as I'm concerned.
So I got to read a section just real quick. So you could say the driving force is somewhat disharmony within the current state, and that bodies in general want to move more towards a harmonious synchronicity. The stress fields create barriers, and a path of least resistance is formed. That becomes the direction of force and motion. I think that's like straight up what you're saying. How basically there's stress fields, they create barriers. Like, conscious minds create barriers and walls, and a path of least resistance is literally formed to where you have your potentialities of where you can actually exist.
And see, my spirituality is more, I like to think of it as more science-based than, because I think the creator was the ultimate scientist, right?
Yeah.
So I'm not.
That's what Avi Loeb was saying.
I'm not saying.
It's a little girl and it's from space.
I'm not saying that. I'm not going as far as saying that I have a purpose or that it's God's will that I do something, because in some ways, I think that God created the sandbox and He's like, here's your sandbox. There's free will. That's where we get free will, right? There's no predetermination, right? That's the one thing I have a problem with with the hologram. But that, here we are. Here's your playground. Have a wonderful life. I'll see you in the end, right?
Yeah.
I mean, there's free will to a degree.
I'm trying to get there. I'm trying to get to free will.
Well, free will can only go so far based off that path of least resistance. Like, you can try to go this way, but it's going to create spirals of delusion that ultimately.
The only thing that limits us is our toolbox. That as far as our free will, we're limited as humans, and we're limited as far as our brain power. So I think that's our only limitations. I don't think we have any other. We don't have spiritual limitations. We don't have consciousness limitations. It's just it's an atmospherical. It's an environmental thing.
So
good.
I was going to say, so okay, say we have this path of least resistance, and then we have free will, and we hit the walls of our spiritual, what I call spiritual potential, right? So as we hit our walls, it makes us spiral back to the path of least resistance. So it's like the turbulent flow that exists within the laminar flow of your creation. Do you see what I'm saying? When you hit the walls, you hit turbulent flow.
I think entropy is more related towards the path of least resistance. I think we can guide our energy if we have energy behind if we have the energy to guide, we can guide our. I don't think that we just push something and it just goes the path of least resistance. That to me is like chaos and entropy. But if I want to go in a certain direction, I can guide myself in that direction, right? So it's not, and it's probably different levels, like how quantum mechanics acts different. Like quantum mechanics acts different. Things in that realm act differently than they do in this one. It may be the same way with spirituality. That on the smaller level, quantum level, it acts the way you think it acts, and then on the the more macro level, it acts the way I think it acts.
But I think your thinking, your action, you are energy, and now you interpret that in your brain as this is what I think, and so you go in that direction. But that might be, in the grand scheme of the energy of the universe, just the force that makes that the path of least resistance. Like, nobody's getting in Tony's way. You know what I mean? Like, you're the energy that forces that function. I mean, we've
learned not to do that.
Yeah, we don't do that anymore. Not after last time. But I mean, so it's kind of, it's like, I think that we exist on the surface of the black hole as the universe's mechanism for the law of conservation of information, where our heads are stuck to this fishbowl and we're observing everything that transacts or that would transact inside the holographic universe that is the space that's at the bottom of that Rosen bridge, and it's accelerating and it's blowing out as space-time. So we're actually the information recording what it was in there, but by the time it blows out of the surface of the black hole, it's just neutrinos, it's just space. So there's no paradox, information paradox. Nothing falls into the black hole. It's so clean that it's impossibly clean. And I think I have a hard time. I want to say we have free will. And I really do think that I suspect, because here's the thing, the UFOs, and this is probably a whole nother discussion, but I think we're looking at them through wormholes. When you see a UFO zipping around at night and there's a bunch of bright light, it's because you're looking into a wormhole in the future where the sun's shining. And I think, when you see in their phantoms, like those Ukrainian scientists said, that's when the wormhole leads to the future, and that's when it's nighttime. And so I think we're seeing ourselves, and the reason that, the UAP report came out and there's been like 195 new sightings, and they're pretty much all Air Force pilots saying, hey, these guys are like crowding our training areas, it's because it's military craft in the future, and we're looking at them through wormholes today. And I don't think the military cares that much about it, because my buddy is the head strategist at the Pentagon. And I said, dude, I know you think I'm crazy, but just write a policy today that says quantum flight, you're going to be here in this place, you're going to fly in these corridors, and you can control them today with a policy you write right now, because that policy will go into the future and they'll follow it. So you can actually control them from right where you're at, if I'm right. And so that's why I think that the military is just not that freaked out about it anymore, because they know it's us in the future. But if it's us in the future, that means when we see one of these UFOs, zipping around, and it's a military pilot from, 2050, you know what I mean? Like, that means 2050 already happened in the future. And so time exists.
That's the only problem I have with it, or the paradox is,
And well, I don't think there's a paradox. I think it happens. Like we are seeing time exists. There's
what happened when they came back, and what were the effects when they came back? We made these policies about UAPs, and that could have affected their future. Right?
And that speaks on the fractality.
Well, it did. Yeah. It does.
Yeah.
I mean, and so the thing is if it does exist, there's no grandfather clause, because all time exists at the same time.
All in the now.
Yeah. And only now exists, but all nows exist. And so if there's no grandfather clause or whatever, it can't happen because it already did. You see what I mean? Like, so in some ways, the reason it all fits is because it's
That
all
seems like
there.
a loophole to make it work out.
Well, right? I mean,
Yeah.
yeah, but it's a perfect loophole.
Well, that's
Even
why
though-
I like to use.
and that's not the way I want it to be. I wish there was free
Yeah.
will.
Well,
I think I hate to admit it, but if I had to
but
guess,
at
if I
some
had to guess,
point-
I
at
think
some
it's just
point in
us
time
figuring
you
things
had,
out.
but
I'll be right back.
at some point in time you had free will, right? If
I want, yeah,
the cycle
wanted it. I
started,
thought I did.
right?
Well, but see, but
The cycle
it's
had
all
to start
time-
somewhere.
That's the thing. That's
We didn't
the
have
thing.
time travel when we were first, we first evolved. So,
Well, I don't know. You mean
well,
in
that's
the
true.
Bible it
That's
says
I
Elijah
just
in the
realized
Bible it
when I
says
said that. Yeah,
yeah, in the Bible it said Elijah caught a ride to heaven on a flaming chariot.
I was just going to say if what you're saying
Was
is true,
it a chariot?
we wouldn't have to
Was it a
time travel.
UFO?
So I think
Yeah.
an easy way to see it is so the crystal itself could be like a river that's constantly flowing downhill, and there's erosion, right? So the now state of the river is the crystal of time, the experience that exists in the now. But as things change, like people go back in time, or people hold postures of delusion, meaning like try to force against their spiritual potentials, they distort and change the surface of the river. So, but the river only exists at a certain shape in the now, but it's constantly changing based off erosion.
I'm just sitting
Okay.
there thinking too.
Yeah,
that makes
I
sense?
can see that. Yeah, I
Yeah.
can see that.
If even if what you're
Now's now, but the next now could be,
The next now could be slightly
little
different
eroded.
based off erosion.
and which is the
thing,
same
too.
as going through, hitting the hologram here, and then coming around, and it's a little different reality here, and then coming over here, and yeah, I could see that.
Always
that
changing,
evolution.
but there still is the concept of the greater now. But the greater now
The thing
changes based
thing
off
is,
of
too,
personal postures.
The thing is too, there's nothing that stops somebody from doing what I did when I was young. Is I had a goal. I wanted to be a design build contractor my entire life. Right. My mother, when I was 4 or 5, she bought me Lego logs or Lincoln logs. You remember Lincoln
yeah.
logs?
Old school.
So
yeah.
I said, I'm setting this path. I'm determining where I'm going. Right. There's nothing that keeps someone from doing that, even though they live in a different reality. That maybe their overall reality may be right. It may be that they didn't. Maybe I forced that, and I had that free will, but there's still this other system that we're in a big bubble. Like, you know what I mean? There's
Yeah.
a systematic bubble, but I still have leeway to operate a certain way, a certain amount of way inside that bubble.
Yeah.
I don't know how you get around free will. If people, you choose to be a doctor and this guy decides to be a lawyer, are you telling me that I was created with that?
That's your path of least resistance, and I think that's where Brad would go with it too. But I don't want to put words in his mouth. But I would say that's your natural path of least resistance. Like when I leave this room, I can only go through that door, or I can go through the 2 windows. I could try to go out that wall.
Oh, I can go through the wall because I know where the studs are. But
you get what I'm saying, though. There's a path of least resistance. So most humans will choose to go through the door. And so you have a path of least resistance. And if you try to go next to the door, well, you're going to bounce off the walls and eventually go through the door. So there's limitations to this, what I call spirit potential. And when you hit those edges of your spirit potential, you spiral into a delusion, and then you go back towards your natural path, which is contractor. For me, it's this right now, whatever the heck it is I'm doing.
Sure. I mean, and I think what you're saying is that's the stationary action. Like, I think in some ways that's just a linguistic interpretation. Or I'm hearing the stationary action principle, which we talked about, which is the sort of the colloquial path of least resistance in physics, that, when you throw a rock, the rock travels that parabola, even if it thinks it's flying of its own free will. Right. So in a lot of ways, when the Big Bang happens, in some ways, the Big Bang could be kind of just like a really complicated throwing a rock, and everything was going to transact just the way it always was from the very beginning of time, and it was never going to be any different. But as we're flying through the air, because under the misimpression that we're flying because of our own free will, in some ways, we're just, it's kind of, in some ways, it could be like the Matrix, where, the movie The Matrix, where you've
Yeah.
already made the choice, but now you're just trying to understand it. Like you're already gonna make it. And in some ways that's consistent with faith, where it's like, God knows the end from the beginning. Or the UFO's zipping around and it's from 30 years in the future. And so it's already happening in the future at the same time, because we're seeing it right now in our time, because all time might exist simultaneously, which is the core of, the Einstein-Rosen bridge, where you're bridging two places of exact same space, but just in different time. So like, I didn't make that up. So, and at some point, like, it would be cool I would love to talk about anti-gravity and how that wormhole's created.
If you want to, I mean, Artisan, if you think so, this might be a good time to do that. Just because we've already been going for quite a bit.
Yeah, I was going to say, I definitely.
Oh my God, it's all like an hour and 40 minutes already.
That's what I'm saying. Like, we might want to get to your anti-gravity device pretty soon.
Either that, or I want to have another show, where because we obviously took a long, but I think this has been a great conversation about, because it encompasses so much. The free will is a big thing for me. And I would always teach my children that they had free will, whether they did or not. Right. Even if I was this immaculate, eminent physicist, and I knew the entire truth, I would still say, kids, you can do anything you want. You can, you just put your mind to it. There's a bit of, and see, that kind of goes back to the, not spiritualism, but it goes to the philosophy of, you have a short life, you want to enjoy it, you know what I mean? So if we're going to be stuck on this rock in space and we're all doomed, why not be able to enjoy it a little bit? Before you die.
See, you're the energy. You are energy.
Yeah.
You're part of the universe.
I
The
always
universe
see
doesn't
going off
happen
your
to
path
you.
of least resistance as stress. So like, stress creates distortions within your natural self, and it guides you back to like the least stressful life, which is the laminar flow. But you can use your will to bounce off a stone and take a different path. But then, like, how long does that actually last?
Yeah, well, I mean, for real, like, here's the thing. Like, if you just throw your hands in the air and let the chips fall where they may, and then you end up being like living under a bridge, for the last like 10 or 15 years of your life, you will know that it was your destiny to live under the bridge, because that's the choice you made, because you threw your hands in the air and whatever. You're not destined because you're a victim. You're destined because that was your energy.
You control your destiny. I don't think it's predetermined.
Yeah, well, I mean, I don't know if it's not predetermined, but I think it might be predetermined that you're going to be a glorious design build contractor because of the energy that you had. Like, that was, in some ways, that's the path of least. That was the inevitable path.
I'm going to quit tomorrow. I'm going to resign. I'm going to close my company down.
Okay, so do that. Now, then feel your spirit. Really, really look inward and feel your spirit when you do that. How long will it last? How long can you actually not do anything?
Well, I would have to do something, but
right, and you're going to end up being successful at it.
The thing is, I came to this point after I left high school, and I went to a building trades class or school in high school. I went half a day to high school, half a day to a building trade school. They don't do that anymore, which is a shame. But when I graduated from high school, I could have gone into. I started to go into college and did a degree or whatever. But the problem is, those 5 years are the prime of a carpenter's life, right? They're the years that you're learning, you're developing your skill, that's your apprenticeship years. Okay. If you do that, you I'm not going to say it's a waste, but you come out with knowledge, but you're already halfway through your prime when you get out of college. Right. So I decided to go ahead and get 5 years of experience. And while during that time I was subcontracting and getting experience. I guess what I'm saying is I could have chosen the architect path, right? I could have. And I made that decision consciously at that point, because my mother was like, go to college and become an architect. And I'm like, no, I want to be, so I could have chosen either road at that point in time. So, you know what I mean? So I guess I think, I don't know. I don't want, even if you convince me to a certain degree that we don't have free will, I'm going to operate that way.
Yeah. And look, I say this, I used to say it all the time. I don't really say anymore, but maybe I should. I'm not trying to change anybody's mind. I like you just the way you are. You know what I mean? Like, if you listen to my podcast, you're just choosing to surrender to my sonic gravity. You're going to orbit in my sonic gravity, and you're going to see the universe through the eyes of a madman, And
yeah,
I don't like, people don't believe it or people don't like it. Like, that's cool. Like, I just, that's.
I like it. I think Kurt Jaimungal liked it. I think a lot of people like it.
Yeah.
I just don't think it's been well heard of yet. So I think that's important, is to get the word out there. So guys, if you're watching right now, this is my little plug for Brad. Check out Sonic Gravity. I believe that's the YouTube channel name. What's the?
Oh yeah, sonicgravity.us is my website. That's where all the podcasts come out. Yeah.
There you go. So guys, check it out. I'm doing your plug. I'm doing the plug.
Hey, thanks, Leslie. I appreciate that.
Yeah.
Well, and see, to me, I would always be that positive propaganda parent, right? So even if I discovered that we live on a hologram and we don't have free will and everything's predetermined, I would still propagandize my children in a positive manner. I would still teach them.
You got to help them find that energy.
And I would make them do what I had to do. Wait till you're 60 years old to start hearing some cool science, cool stuff. But at least to that point, they would have felt. I think their psyche, their psychology, their mental health would be healthier if they thought they had free will.
That translates a lot back to when I was teaching Taekwondo. Like, some kids are better than others, right? When it comes to physically doing Taekwondo, like one kid's clearly going to win the battle, but it's like you need to always give them that inspiration. The second you instill doubt or like you're not worthy or that, then they will take that path of least resistance, right? Like where they'll still do the same things, but they won't have confidence in the things they do while they do them. Like it's better to have like happiness and heart and strength when you do your own things.
I'm still holding out for the fact that matter, takes the path of least resistance. But once matter becomes molecules and molecules become cell and cells become humans are special, and we get to control the path.
Well, and that's where
I'm not saying that energy doesn't take the path of least resistance.
So I always think about it
on this level. I think we have an exemption or a loophole.
What is our most advanced sense? And you guys' opinion. So I want to let you go first, and then I want to say what I think. Like, what is our most advanced sense? And this relates a lot to what Artisan was just saying.
I always thought. I mean, I know thought is not a sense, but the gift of thinking is, to me, should be like the sixth sense.
And my answer might be extremely woo. Is also the kind of the point I'm getting behind it too.
Now, I'm not sure how you define sense, but if I had to, if there's magic in our consciousness, I think it's memory. And that's because that's our function in the universe, to record, to observe. And
I wasn't expecting that answer, but I love it. Keep going. Sorry.
Cool.
Actually, I do like that. Yeah.
Because I think, like I said, I think we are observers. I think consciousness observes, and I think intelligence assimilates, and I think emotion remembers.
I was kind
of because you'll remember things, how somebody made you feel. You'll remember that shit for fucking years.
I'm gonna have to.
You'll forget somebody's like name, or whatever. But if somebody makes you feel something, mad, happy, whatever, love, you'll remember that shit for years. And I really, to be honest with you, I think it's emotion that sticks you to the next black hole. When you die and leave.
That's what I was getting at, almost.
That's why my intuition told me, like, the sense of thought, just the ability to be able to think. Because to be able to think, you have to, remember things as you learn, right? Well, that's pretty cool.
So I think I really like both your guys' answers, just so you know. Like, I think they're awesome. But I was going to say love. Like, it comes down to our sense of potentiality. Like, if I go this way, will I receive love or will I receive hate? And it's like, you receive hate, you bounce off. Hate, bounce off. And then you find your path of least resistance through love.
It's the ultimate motivator.
Have you seen the Physics of Leadership? Have you?
No, I haven't seen that one.
One of my earliest episodes, The Physics of Leadership. And it's exactly that. It's that, when it comes to leadership, right? And because when you're a psychopath, when you're a bipolar autistic psychopath in the military, you can't lead like normal people. You need an algorithm. Because I'm retired from the Army. And so so if there's three things. One, people want to do the best for themselves that they can. That's one. Leadership transacts in people's minds and in their mind alone, in the unique soup of their brains. And three, how you make them feel about themselves is going to determine your outcome. And that's all there is to it. That's all there is to it. You can fit every single thing that you ever learned or saw in leadership into those three, into that paradigm, and it will all work out. You'll see that that's what it means. And the reason I came to that was because I was like, well, if leadership exists, if people can lead anywhere, there's either a physics to leadership or there's not, right? Binary. There's either a physics to it or there's not. And we know there are good leaders because there are some people that get repeatable, predictable results. And so if good leadership exists anywhere, then the physics of leadership must exist everywhere. And it's
I agree with that 100%.
It's the impact of how you make people feel about themselves, just like you said, with like love. That's how you lead.
That's how you want your students, your Taekwondo students, to feel confident. You want them to give them the value of self-worth. You want them to feel better when they're around you than when they're not, right?
And you can do it with rage too, right? Fear. You can lead with
Right.
You can lead with fear. You might get some more dysfunctional results, but it's that emotion. It's how you make people feel about themselves determines your outcome.
And
I think that love is what motivates me to want to teach my children a certain way, for their mental health, right? Sure. I love them and I want them to be happy. So that motivates me to teach them, whether they have, the free will or not. I want to teach them that way because I love them and I want them to have happy lives. So,
well, especially if they're having negative thoughts, you want to say, hey, you have a choice. You can change the way you're thinking. You can change what's happening, right? You don't want people to think that it's completely indeterministic and completely deterministic and that they have no hope, right? You want people to have a sense of hope because we all do have, in my opinion, within the greater flow of creation,
sure,
we do have free will, but there still is that greater flow of creation. But within it, we can choose to do whatever we want. Like I could throw my water bottle at the wall right now if I really wanted to, but then I couldn't drink my water and I'd have to clean up a mess. So it doesn't really make any sense. So but I would still wake up here tomorrow, so we have free will within our emotions, but we can only go so far, in my opinion. So this is where it's my opinion.
Yeah.
We can only go so far before we bounce back to the natural, what I call faucet of creation, which you would call the neutrino drift. Like you have to be connected to your freaking your flow of time. If not, you won't even manifest.
But don't throw it because the path of least resistance is to don't throw it? Because if you don't throw it because the path, do you see what I'm saying?
Now you got me thinking.
It's a self-licking ice cream cone, because you can say like the energy that would take to clean it up and then I'd be thirsty and all that kind of stuff. So maybe that's why you don't. That's maybe
he did that for being funny, but I guarantee
he's trying to don't be. He does. He's fighting. He's fighting.
Within the next month, you'll have that cleaned up.
No, if you notice,
for 3 months.
Put the top on really
he'll
tight
leave it forever.
I put the top on really tight before I threw it. But
but it's just, it's kind of one of those things, is it? I don't know if I could legitly tell the difference. Yeah, see.
But did you right?
But did you do that because your energy said, "I will not be bound"? Are you fighting fate? Because if I would have told you, no, you're going to throw that bottle. If I would have told you that before, because if I knew you were going to throw that bottle, and I said that which I thought would get you to throw that bottle, did you throw it because you wanted to resist it, or did you throw it because you really wanted to?
That's my point.
Sorry, go ahead, Artisan. Go ahead.
I was going to say, if we don't have free will, who is controlling our will?
Well, at that moment,
I think it's unified consciousness, right? On the primordial black hole. I think it's God.
At the end of the day, there's God. So that's where I have a hard time thinking there's not some like ultimate fundamental force or creation. And maybe it is just a collective creation. I don't know. But I really do think there's a fundamental force. I think that raw energy of prana or neutrino flow, whatever you want to call it, is drifting inwards constantly.
But if information can't be destroyed and it's in our consciousness and it leaves the surface of the black hole as Hawking radiation, where does it go?
the next realm.
if not another black hole.
It just
Right,
gets
that's what I'm getting
dispersed.
at. It goes to the next
There's
black hole.
plenty
of
of
eternity.
space. There's plenty of space for this information to get dispersed to.
Well, I think we in fractal ascension, and Alexei likes this. We go to the next black hole up because we know there's black holes in our universe, which means if that's a universe, you know, there's black holes inside that one, inside that one. That's the multiverse. It's black holes inside of black holes is the multiverse. And then when we essentially look out at the cosmic microwave background, when we die, our heat leaves our body and leaves the surface of the black hole. If we're black holes inside our black hole, that means our black hole is probably inside another black hole, and we go up a level, and maybe that's reincarnation, or maybe we're like me, where I believe Christ is my savior, and I go to the primordial black hole, the very first black hole. Yeah, right.
Sorry, I was just
But
laughing
then-
at. I was laughing at Andy's comment. Did she? Throw, how many people just threw a water bottle that are watching?
Oh no.
I know. But did you throw it because you weren't thirsty, or did you throw it because you wanted to believe that you had free will? That's
I wanted to believe I had free will, but the truth is, it's already back in my hand.
But if I would have said if you did throw it, you didn't have free will, would you have kept it?
I'll have to think about that.
Yeah. Now you're just being controlling, Brad. Okay?
I'm just asking.
I don't.
Seriously.
I'm not choosing to think about it right now. I'll think about it next time I watch the show or think about it later.
Yeah, and Ains like black holes all the way down and all the way up, probably. But I think when you go all the way up, in my mind, you're getting another dimension each time. You're getting because you know, and so that's why I'm not sure if it's lower density or higher density. You and me are going to have a beer and sort that out.
Well, this is where I go into physics, right? So when it comes, you were talking about orbits earlier, and there's a certain distance where the velocity is faster than the speed of light. So the further you go outward, in order to maintain an orbit, you need to go faster. The closer you are to the center, the slower you're going. So I personally think that
that I completely believe, and
you know what I'm saying there, right? So
and more massive.
You know, I also like the vortex, becoming more dense as matter creation. Right. I mean, that's the way I like to visualize it.
So I think of the outer realms as more primordial, the past, the less dense. I think of inner realms as the future, the more dense.
Well, so are we talking about density as in matter?
As in distance from center of the greatest blach hole of infinity.
Because can you look at it as a matter of density, and the closer to the center of the vortex,
and each one of those orbits creates the depth based off of our current layer. Is that making sense to you?
Yeah, and one thing though is that when we look into the cosmic microwave background, right, that's the oldest radiation, which reflects the densest the universe was ever before, right? Because right at the Big Bang. So
I get what you're saying, but currently it's the least dense.
Yeah. I mean, it's distance, and I saw this on
PBS. I get what you're saying there. Just so yeah. I get that.
Is that time and distance sort of flips in reality at the surface of a black hole, and that's not me. It makes sense, and it's built into the sonic gravity theory of everything. But that's actually from Dr. Matt O'Dowd on PBS Space-Time.
Yep.
And so that's where I would say look up into the heavens, that you're actually looking at what it looked like. Well, it's not. Further is what it looked like when the black hole, when the singular, when sort of the Big Bang happened. But in a lot of ways, the further out you look, the denser the image would be, because if you went ostensibly, if you looked all the way out, you would see
all the way at the very edge. At the very edge, it would be equally as
you'd see the Big Bang.
Yeah, no, I get
the Big
that.
Bang.
So I think that there's big bangs at every multiple of the speed of light as we drift inwards.
Okay, I will try it.
Isn't the universe expanding in all directions though?
Yes, but from every point in space and time.
So you wouldn't see the actual.
I think it's every black hole. So I think there's space-time. There's space-time ejecting out of the black holes.
How could we test that? Based off of undulations of the cosmic.
If you map,
we have basically mapped it. Right?
If you map the local black holes, like black holes around us, and look at it as a fluid dynamics problem based on the mass of the black hole, and try to correlate that with the pressure of space-time blowing out of it, I think you should be able to probably reconcile. And this is actually, I'm going to talk a little bit about this in my next podcast episode, but the models for space-time expansion between Dr. Brian Keating's work with looking at the cosmic microwave background as a metric for universal expansion, and whoever the other guy was that was doing the celestial bodies. So, I mean, it's just, yeah, the way you test it is you would try to map the black holes that you could see and see if there was space-time blowing out of every one of those other black holes. What's that look like?
All right, let me ask you what you think about this idea. Do you think, okay, so as we get closer to the center of the Earth, or if we were further out, we get closer to the center of the Earth, the force of gravity becomes greater, right? Did we lose Brad?
No, say again. I'm sorry.
As we get closer to the center of any body, the gravitational force gets greater, right? It's 1 over r squared, basically.
Yeah.
So the point being here is, say we're drifting in from the most outer edges towards the greatest center of all moments. Wouldn't the universe naturally look like it's expanding based off of the inertial reference frame?
Okay, say that one more time.
That's the premise.
Say that one more time. Can you say that one more time?
So from a fifth dimensional view, like where we're existing within shells and shells and shells of black holes, as we're drifting towards the center of this greatest black hole, we would be undergoing more gravity, like a higher force of gravity, causing the universe to stretch and stretch and stretch as we drift inwards. Because it's all about relative motions.
Yeah, I think that makes sense. If we're on the surface of a black hole and Stephen Hawking said the black hole is evaporating, it's getting smaller, I think it's because it's blowing out space-time, and as the space-time blows out, sort of the pressure of the tension in the Higgs string, like, say the core of the star goes out here, big bangs, and as the space-time blows out, the Einstein-Rosen bridge is getting shorter and shorter, and the black hole evaporates and is empty as soon as all of the space that was at the bottom of the Rosen bridge is uncoiled into our universe, and the space-time is healed. So
isn't the current
that's a more
model
descriptive.
that dark matter is
I like that.
That's why I think space-time's blowing out. It's the tension in the Higgs field, it's the gravity that is pulling the space back into the parent universe that's causing the black hole to abate. And the more space-time uncoils and the more the universe expands, the smaller the black hole gets, and eventually the space-time is healed.
Real quick, do you think we could take a picture inside of a black hole by creating an accelerative reference frame that's going towards the center of it, meanwhile using a camera?
Yeah, I think we're looking into it right now from the surface of the black hole. I think everything we do and see is a picture of the inside of it.
I said no, didn't I, when you asked me that question?
That was on Twitter. We were talking about that. You were like, but you can't see into the black hole. And I was like, well, if you just change your accelerative reference frame to be relative to the inside of the black hole, then you could.
But the light in front of you would be attracted.
And at the end of the day,
like,
the machine would tear apart.
Here's 2 photons traveling towards the center. You can't see the one because it's trailing, and you're trailing.
But there's a difference between acceleration and there's a difference between velocity, right? So you can be going in that direction, meanwhile accelerating in the opposite direction at the speed of light.
Well, acceleration indicates a change in speed, though.
Velocity
is just the amount of speed that is the measurement.
You're muted right now, Brad.
Uh-oh.
Yeah. You can't. Well, the speed of light's a velocity. It's not an acceleration.
That's my point.
Yeah.
So if you accelerate it inward, then you would have a. So it's all.
Are you slowing down?
It's also about inertial reference frames, and part of the inertial reference frame is the gravitational force, and not in your theory, but in the other theories, basically the force of gravity is what's causing the black hole to be formed. Right. The Schwarzschild radius is where the acceleration due to gravity is equal to the speed of light or greater. And so when it comes to actually taking a photo inside of a black hole, if you created an accelerative reference frame that was towards the center of the black hole, now you would be in the same frame of motion as the energy that's existing within it.
Okay.
I don't think any light in front of you would see.
It's a thought experiment for anyone watching.
Yeah.
Let's just keep it at that. Yeah.
No,
the light can't enter the sensor of the camera.
If
the
you're
light can't
accelerating
enter the
this
sensor
way,
of the camera because it's going towards the center of mass. the center of the
Well, you
black
can't
hole.
see anything behind you then. I think
Exactly.
you
You
can
wouldn't
see
see
things in
anything
front of you
behind
because
you.
they're coming through, but you couldn't see anything behind you.
Yes.
Because
I
the
think
light
you're
would
seeing
be
it right,
chasing
yeah.
you from behind you, but it would never get to you.
Right. But the second you change
Well, it depends on which way you had the camera
turned.
turned, I guess.
Sorry, Brad, for some reason you keep muting.
It's because I think there's a dog playing with a squishy toy, and I didn't want to bug you with that sound.
It's okay. We don't care.
Very cool.
I wish we could talk about this. I'm going to have to go in a few minutes, but I want to do another show on the anti-gravity stuff. So
we didn't even touch that yet. Yeah,
dude,
I know,
this
but
thing, it was like it just went like that. Like
I think
don't know,
it deserves. I think it deserves its own show, though. So
yeah, let's do it, man.
I like how we talked about spirit potential or neutrino potential, or just in general the path of least resistance. I think
and
cool.
delusional fractal impacts and bouncing. That man was cool. I feel like we're all kind of catching what we're throwing, right? I mean, what now? So tell me, tell me, Tony, what do you think? Are you feeling the hologram a little more?
I'm moving. I moved a little bit. I think if I can get away from the rigidness of it, if I don't have to give it my free will, and
your free will is gone.
Can't have it.
But no, I'm digging it. I'm digging it all. Again, I always try to listen to what somebody says without any kind of bias. I really do. That's a really hard thing to do. I admit, but you have to listen to every human and try to, put your bias over here and then if you want it to bounce back and come, and maybe the path of least resistance for bias is it comes back in your head. I don't know.
That's what happens. It bounces. Yeah.
But no, I think it's cool. I love the discussion, and that's why I invite you guys here.
Brad, I was on
it's an honor.
I was on Lou Jimenez's show, the Unidentified Celebrity Review, talking with Michael
Mataluni.
That's right. Yeah. And while I was speaking with him, he was like, "You know who you need to talk to? Bradley Boris." And I was like, "Oh man."
Who said that?
Michael.
Oh, Mike did?
Yeah.
Oh, yeah.
How do you pronounce your last name, Brad?
Voorhees.
Voorhees. Okay, sorry about that. Yeah, thank you.
Yeah, I wasn't trying to point that out because you said it, because the reason I asked was because there's another fella who has 2 E's in his name. It's Gary Voorhees.
Oh, Voorhees with an I. Yeah, Gary. Yeah.
Guy
who does UAPX.
His name is spelled a little differently, right?
Yep.
You're not related. You're not related, but it's pronounced the same.
I definitely threw in though on his truck because I wanted a spectrometer on it, because like we talked about before, which we'll talk about next time. I think we're seeing these UFOs through wormholes, and I said next time you catch one of these, I want you to zap it with that spectrometer. I want you to tell me whether or not that's daylight or not. Because if it's daylight,
I almost brought that up earlier because you can tell. You can tell based off the spectroscopy of the light coming out of it. Is it Earth? Is it our sun? Is it a different sun? Is it our sun in the future? Like totally. Yeah.
Well, I have to address this before we go, because see, I said that God, or the Creator, created the sandbox, the playground for us. I don't think God had a plan for my life. I believe He created me and said, "Here's the earth. Here's your playground. Here's all humans. Love them. Be good to them. Be good to each other. And when you cross over, I'll see you again." I don't think that God had a plan for my life. So,
well, I mean, He
said I had to surrender my free will. I don't think I did.
I don't know, because if I just say, "Hey, that's what I want to do," if I decide that of my own free will that that's the plan I want to follow, God, let me know what the plan is, because that's what I want to do. Then I'm doing it because I want it,
Right. It doesn't mean you don't get a little assistance along the way, but you still get to make the right. Yeah. I don't honestly.
And I'm arguing against myself now.
Well, see, the thing is too, I have a very, even though I grew up in a Southern Baptist church, I have a very controversial theory on prayer. I think prayer is only for worshiping God, not asking for things. So you have people, I don't believe that you can sit around and, well, I think it's obvious. That's what we observe, right? Again, I'm a semi-scientist. If I could pray for things and it can't work, I would just there would be no cancer, there would be no hungry people, there would be no homeless people, right? So I think that's where when we fell short, I don't believe in necessarily the literal Garden of Eden, but when we fell from that grace, we gave up our ability to get that help from God. And that's when free will actually was created. At that point, you're on your own. I'll see you in the end, that kind of thing.
Tony, how would you feel if your kids made a mistake and then they felt like they couldn't ask you for help? What would you tell them?
Well, but how much power do I have to help them, though?
Well, you're the daddy.
No, but what if my child, God forbid, Jesus even say this, got cancer?
Don't say it then. Don't say it.
I can't cure cancer, right? It's the same thing. I can comfort them. I can love
frequencies
them.
Between 100,000 and 300,000
I can make them comfortable, but I can't cure their cancer.
I don't know, man. But I don't know if one of my girls or one of my boys needed something, I'd want them to ask, even if I couldn't give it to them.
Oh, well, I mean, I still treat my kids. Barrett's 33. I just went on the day before Christmas and helped him unfreeze his water pipes.
Nice.
So I would do anything for my kids.
Yeah.
But that doesn't mean I can control them.
Sure. Yeah.
Yeah. I never asked Barrett. Barrett's a musician. He has his own musical studio. I never asked him to become a part of my construction company like every other contractor dad does. I gave them, because I believe in free will, I didn't say a word about it. I just said, of course, I did play rock and roll when they were kids, so that might have influenced them musically.
Yeah, man.
But
I think that circles back to the idea of selfishness versus selflessness as well. And I could go on about that for a while, but I don't think we should.
No, I like that though. Selflessness is like is part of that love equation, I think.
It really is. And especially if you're trying, and then we talk about the delusions. Like if you're caught up in a fractal of human creation and you're supposed to do these things that man has told you to do, but that's all just man-made nonsense, in my opinion. Then you have like what you feel in your heart you're supposed to do. That, in my opinion, is from the greater laminar flow. So but it's all opinion. I'm just making that clear.
No, but I mean, that makes sense. Yeah. What you're talking about might be a manifestation of the stationary action. And it's like maybe the stress is that turbulence from deviating from it. And so I get when you're saying you're bouncing off things and you're calling that delusion, I think it's just language. I think if you
when laminar flow when a laminar flow gets to its edges, it becomes turbulent, and then the flow returns to normal. And so I think of that as the fluid of experience drifting inwards to the center, like that neutrino flow, you could say, drifting inwards to the center, or drifting outwards in your case. When you hit to the spiritual boundaries, it creates a turbulent flow because you've disconnected from the laminar flow. And you ultimately bounce back to laminar flow. If not, the prana, the chi, no longer will power the body, and you literally pass away. Like you need to be in the laminar flow.
To me, that just sounds just like the stationary action principle, where you have your kinetic energy minus the potential energy, and the minimum action is that laminar flow where you're always going to go. And if it was to vary off of that, then it would come back to it. So it's like
it's the pacing about a perfect center.
Yeah. So I think at least what I'm hearing you say is just a different language where you could actually be describing physics and the stationary action principle.
I mean, maybe it is that. I've never actually, so that's where I never learned that concept. But for me, it's all about fluid flow, and there's turbulent flow, and there's laminar flow. And our bodies are a creation of laminar flow. Our free wills will take us into a turbulent flow. But that's a selfish existence to where you become like in your own little spiral of creation, and you're not connected to that greatest flow.
When I first talked to you, I had this image of life being the river of life was the laminar flow. That was the kind of a thought I had when I first started talking to you, Alexei, about
I think that's on point in my opinion. But it's again in my opinion, right? So just to make that clear for all people watching, they can all have their own opinions.
Everything what's funny is our automatically caveated with it's our opinion, or maybe this.
Well, it may be like that.
I'm not going to be like, oh, you said,
Well, I think what it's going to, in the end, it's just
My
like,
opinion is fluid.
I think in
Yeah.
the end, when we'll find that the God is not the God we necessarily think of, that all of our, the Islamic God, the Buddhist, or the Christians, the Catholics, the Protestants, whatever, we all think we have, that's our God is their God, or our God is our God, and theirs is theirs, right? I think in the end, it's like with all these theories, we're going to find that it's a combination of everything, right?
Yeah, I think there's
And,
a lot more that makes us similar than makes us
yeah.
dissimilar.
That's what I was going to say.
I
Spirituality.
never understood why quantum mechanics couldn't just be part of relative. I never understood why there was this big argument back in the day when I was a teenager. What, the 70s? There was always this argument. No, it has to be. You have to. Why can't? I don't understand why it's not just.
Well, I mean, I just gave you a model of Rosetta Stone of the universe that reconciles all of it with the U1 symmetry. And the
I know.
UQ
I was
symmetry
having
and
that
Higgs
thought when
and
you were. I was
that's
having
it
those
right there.
thoughts whenever.
It's right
Yeah.
there.
Yeah.
I mean, I don't see how else you get there. I'd like to
That's
know.
why I say I moved a
how somebody
little
else
bit.
can do it.
And I think our ideas line up like perfectly. And again, I don't see how else you get there. Like, I think that's
Yeah, I don't.
And I
I
think
don't.
very
the time-
close to, in quotes, truth, as you probably will get as a human trying to perceive reality.
Yeah,
And I think it
I
could
didn't make
be-
a lot of this stuff up. I didn't make it up. Like I just learned what really smart physicists thought up, and I just learned it, and okay, I understand that. Next,
And you
then
have
I
the
was just
math
like,
all on your
here's
stuff.
yeah. I was like,
Yeah,
here, I think it
it's
all
there.
goes like this. You can say I'm wrong, but you can't say it's not plausible.
I don't think
can't
I'm
say it's
qualified to tell you you're wrong.
I'm
no,
not
but I mean,
qualified to
I'm
say it
saying
either.
anybody.
I say it's highly plausible.
Yeah.
I think it is. I really do. And it's crazy because the more right I feel like it is, like when I see stuff, I'm just like, oh, that totally fits. Oh, here, I'm making this prediction about this gamma ray burst. It's, and it's just like, the more right you think something is, the less you give a shit who believes it. Because
So
you're just
I
like,
think one thing that would be great is for your prediction about that gamma burst, when does the light hit us?
I don't know. I'm not sure how far it is. Like you could do the math on what the speed of light, how
It
long
might be
it would
100
take.
years from now. That's the problem.
How
I
far
don't
away
know.
is it?
I know that there have been gamma ray bursts in the past that preceded the light from the supernova by 3 years. I know that's happened in the past. I don't know how far that thing is compared, but given the flash to bang from the other one, if it was a similar size and stuff, I mean, I might be able to. I'll bet you there's a physicist who could dig it up and figure it out. I might be able to do
it's
it.
the same as a lightning strike hitting before you hear the thunder. So you have your every 4 or 5 seconds is a mile. So it's almost
except
a
that
very
sound travels
similar
at
thing.
what, 720 miles per hour or something, and light travels at 186,000 miles per second.
Exactly.
All
very
you
similar
need
thing. Your transverse
you
wave.
had-
Yeah.
If you had
sorry.
no, it's okay. Go ahead.
I was going to say your longitudinal wave is going to hit you at one point, whatever speed, greater than the speed of light, then the light hits you. And that should be a common equation. So then you could actually use that and apply that to other gamma ray bursts and visible light.
I think if you had if whatever that GRB was, that one, if the black hole that one came from was a similar size to a black hole that we saw the gamma ray burst hit us and then the flash, if you knew the relative distances and you knew the relative like sizes, I'm not sure exactly how the size would come into it, but if you got lucky and it was relatively the same size and the distance was comparable, you should get the same thing. But we'll see.
And that brings up my last question. I mean, like, what's the time scale of science? We're talking astronomical, cosmological things here that take thousands of years to process at times, if not billions. Science has been around for like 100 years. So it's like we'll have to wait 5,000 years to prove this accurate or something like that.
Yeah, I don't. Well, the thing is that if the gamma ray burst got here, maybe the supernova happened a billion years ago.
Yep.
And so it happened a billion years ago, and all of a sudden we get hit by the gamma ray burst that, took 40 years from the day, to get here from when I was born, but maybe it takes 45 years for the
But gamma rays
know.
travel.
You get what I'm saying. So like
Yeah,
science
totally.
has
It
its
makes perfect sense.
limitations, and based off the size of the universe, like our science would have evolved so many times before light from the edge of the universe even arrives to us. So we're so limited by our life cycles too, and like science is very new when it comes to human existence. Yeah,
relatively.
Well, I have to
Relatively
call
new.
a customer at 7:30, or I was supposed to. So
This is like the longest podcast we've done in a while.
I love it though. I don't want to quit it, but I have to call this person.
Well, let's set up again. You know, we'll do another one.
Yeah, let's schedule another one, and we'll do the anti-gravity that night, that evening.
Yeah, time travel, man. I'll make you
my anti-gravity.
Time travel.
Stack magic squares.
That's going to take a little more force to budge me on time travel.
The gravity will pull you.
Gravity.
You will orbit in sonic gravity.
What did Lou say? I have my own. I have enough. What did he say about my gravity? I don't know. Anyway, it's kind of funny. But
you talking about Jimenez?
No, Lou Helson. Remember we were anyway.
Oh, like yeah. I just said let's forget that. Let's move forward. Yeah, no, I remember that.
Anyway. Well, thank both of you. I'm thanking both of you guys for being here. It's awesome. These are the kind of discussions I love. And I think you can love them if you can suspend your thoughts and beliefs long enough to have a decent conversation. This is what's missing on Twitter, all of social media.
All of social media.
Really, it is really
all modern society.
All media.
There's you can't have a conversation like this without being mad at each other at the end, and I love it. That's my whole goal, is to have these conversations and to still be friends and come back again. If I can get you back again, I know that
I'd love to.
Michael Macalugi was right. He was correct. We
had
a great time chatting it up.
Who said that?
Singularity Mike.
Michael from UCR. I remember being on the show and he was just like, and what's your reasoning behind this? Like totally like, why would you ever think what you're thinking? Kind of.
Yeah. I remember he used to sit there going, you could see it in his face. It was funny.
Yeah.
They were being nice to me. I was on the Singularity Lab too. And
I was on UCR, not the Singularity Lab. Yeah.
Oh yeah. Well, and so I mean, but Lou Menace, he was pretty graceful to me. He was like, you got some weird ideas. He goes, but they kind of make sense. You know what I mean? Like black holes or donuts, like that stuff. I have no complaints. Like Mike and Carl Vibe and Lou, like they've heard me, and they're pretty skeptical too about like a lot of people, but they didn't throw me off their show. I mean, Tony,
were you on Carl Vibe's show? Was that an independent?
Yeah.
Thing? Very
cool.
I
was on Carl. I met
him out in Utah actually, which was pretty awesome.
When?
This last year when we were starting up the UAP Society, and I launched a balloon for Chris.
Cool.
Leto.
Okay.
Carl Vibe was out there in Utah as well. We met. We were like hanging out in the hotel, and we were talking about like different dimensions. He's like, "So what do you think you're actually interacting with?" I was like, "Past and future selves." Was my like one line to him.
Yeah. Oh man, he would have ate that up, I think.
Yeah.
So,
how do you pronounce Ain? Ain's name?
Who?
I think.
Ain.
Oh, that's cool.
Ain. How do you pronounce her name? Ain or Ain? Athene. I don't like mispronouncing people's names, so I get a little anal about that sometimes. That's why I was asking you about your name, Brad.
Is that correct?
Yeah, Voorhees. Yeah.
Okay.
I don't know. Like if I ever talked to Lou Elizondo, I'd be like, all right, man, here's what I think. I think it's this. I think it's this. I think it's this. And I would just love it if he would go like, or, you know what I mean? Like, cause he couldn't say anything.
All I can say is you and I have very similar theories. Yours might be more mathematically drawn out. Mine might be more conceptually drawn out. But I don't know what he did, but he passed my work to Avi.
He's a gentleman. He wouldn't do that, or
no. But I mean, I think he knows more than he can say. Like I know he's seen some things.
Yeah,
he said some things that he wouldn't have said if he didn't see it, because I have very specific notions of how UAP or UFOs fly and the propulsion and all that kind of stuff. And I've caught him saying some things that I don't think he would have said if he didn't see. So I know, and like Payas, Payas patents, you saw on Kurt's show, Salvatore Payas. Yeah, he's saying some things. I know he's seen it. I know he's seen it work.
Yeah.
I know. I personally know that there's a lot more information, a lot more scientific research that has been done than that has been revealed.
Yeah.
Yeah.
Oh, that's a given, I think.
I mean, like we have John Searle in 1960 had a craft that could go to the moon in 10 hours.
I think that's just a natural flow of science, and black programs.
No, we have this 5D tech that we're talking about.
I think the military probably has their own version of fusion already.
Fusion was done by David Adair. I believe that's his name, Adair. Look up David Adair. Yeah. He was a guy who was a rocket scientist. He got contracted out by like Area 51. He launched some missiles. He had his own fusion reactor. He's got his own story. That was like 30 years ago, easy, 40 years ago.
Yeah. All right. Well, guys, I hate to stop it, but
too much fun.
Yeah, it's too much fun. We got two good subjects there, I think, to talk about next time: the time travel and the anti-gravity, and actually the UAP discussion. It's kind of funny.
Thing.
It's actually it's one of the same.
People are always asking me, "Why don't you ever talk about UFOs?" And that's what I say. Well, we're talking about the foundation of UFOs.
Yeah. I've heard my work doesn't relate to UFOs. I'm like, no, this is UFOs. Like this is what UFOs are.
But then I go out in public and get poked, by my contractor friends. Well, you're talking about UFOs. Yeah, it's kind of funny. I'm like, no, I'm not. Go watch it. Tell me.
If you guys are down to hang out for like one more minute after we end the live stream, I think that'd be fun.
Okay. Well, we'll end it here. Thanks everybody in the chat. I appreciate it for watching. You all are why we're here. And I really do appreciate it. And thank you, Alexei and Brad. And we're going to do this again very soon. Don't want to say bye.
Yeah, thank you, Artisan, for hosting. Great show.
And thanks everybody for
listening. Brad, thanks for joining.
Thank you guys for being here.
Yeah.